Yes. Okay, welcome back. Welcome back. And we are starting our AI and data science track soon. So to start off, we have Mohit Bhatt. He's a full stack blockchain engineer at Netflix, at Flick Network, project admin and mentor at Google Summer of Code, project maintainer and mentor at CC4T for Métis. So he's here to introduce us everything about agents, AI agents.
Hello, hello. Yeah. Hey everyone, welcome to the session on all about AI agents. Uh, Today we will be developing like an AI agent, a Twitter agent, which can post on your behalf. And before that, I will be talking about what AI agents are and how they work. If you are someone who is very new to this space, who doesn't know like what AI agents are, how they work, and what exactly happens behind the scenes, and why we need AI agents. If you have all those questions, this is an introductory session for you. I think you will get to know and you have a good quick start about how all this space and everything uh, works in this field. So a little bit about me. I think she has already introduced me, but a little bit about me. I am a full stack Web3 engineer at Freak Network. Freak Network is basically a decentralized cloud infrastructure for apps and AI agents. We are like into TEs, trusted execution environments. We provide it over a decentralized network. We have our own fleet network. I'm also like an international speaker, project admin and mentor at GSOC's Core Lab C2SI organization. Have been like building a lot of tools and things in Web3 and AI. And of course, like I have been past like GSOC alumni, Summer of Bitcoin, and have been like an hackathon geek as well. So have participated in a lot of hackathons worldwide, built a lot of things uh, for different organizations. So let's get started with the session. Before starting, like diving into hands-on session of AI agents and building that Twitter bot, I will like to talk about few important terms that everyone should know before starting in this space. So first is LLMs. So what exactly LLMs are? So these are large language models. Okay, these are basically AI models. If I just talk in layman terms, these are models which are basically trained on vast amount of textual data. It has, you can think it has brain. There are a lot of things going behind the scenes like transformers and all of those things are there. But in short, if you are someone who doesn't know what LLMs are, it just, you can think of it is trained on a lot of textual data. It has a lot of details put in it, and it can think, it can react, it can find out the related things and can give you an answer. And I think you already are using this. A lot of people are using this. This is examples for this are like OpenAI, Anthropic, DeepSeek, the Chat GPT that you use, right? So these are basically called as LLMs. Now the next part, which is very important, and a lot of people don't know about this thing, is like embeddings. And this is very important from the perspective not only about AI agents, but in a broader sense. And it is widely used in AI agents as well. So now let's talk about what exactly embeddings are. If anyone has built any kind of AI agent, they would listen this like term embedding models and all of those things. So embeddings are basically numerical vector representation. If I go by the definition, of course, it doesn't make sense like if you are not into this field, but embeddings means a way to represent your information so that the models or any kind of algorithm can easily find that thing. So let me talk like in a better space. So let's say uh, you have a lot of words. Let's say you have a PDF, right? And the PDF contains data about AI and Web3. You have a PDF which contains information about AI and Web3. It has like a lot of sentences, what AI is, what Web3 is. Now you want to build an uh, I will not say AI agent. Let's say you want to just basically build an application where uh, you can search and you can answer things out of this PDF, the document that you have. And let's say you ask the chat GPT, what is Web3? Okay. And you have created it with like this PDF which contains AI and Web3. Now, what you would do basically is like you can um split the document in chunks, let's say by words, like by sentence, like first sentence, second sentence, third sentence, and you have a lot of sentence and you gave it to the, let's say, chat GPT. Now, how will chat GPT will find, like I have asked a question about what is Web3, how it will find what are the sentences out of which what are the sentences which are like very close to Web3 and it can use it for answer. Okay, it's not easy to like do string search. You might say like the first thing that comes to your mind is like I will do like in every sentence is Web3 is there, then the sentence is related to Web3, and then you give it to the chat GPT. But that doesn't make sense, right? You cannot like do it for like so many sentences. It will be too slow to do just string operation and searching in a big sentences. And also it may be there are case like there is no Web3 written in that sentence. It might be written like crypto or something else. So how does like we find the related sentence with respect to what the user has asked? How does this work? So their embeddings help in that. So what I will do, and what the the way like embeddings and all of these things works is like, let's say I have these words, man, woman, king, queen. So I will choose an embedding model. What is embedding model? They have like a lot of parameters, like on the basis of which it breakdowns like whether this particular word is, how much close it is on different parameters. Let's say living being, feminine. This is just for an example, but there can be like multi like parameters on which you are like checking whether this word is close enough to uh, to the parameters. So let's say man. So when you can think of this embedding model as just a function. You just give it a string and it will generate this big array, okay, which is basically called as vector representation, okay, vector values. And what these values are, it is basically from 1 to -1. So one means it is highly related. It can be like any range. It depends upon the embedding model. But let's say just for this example, it is like from 1 to -1. So -1 means it is totally unrelated. 1 means it is highly related. So that is what. So now let's say if I put man in this embedding model, it will basically generate 0.6. So it is very like close to living being. Minus 0.2. Is it like feline? No. Is it human? 0.8. So it will generate this vector representation, and this is like how it comes. And let's say woman. So again, woman is also like a living being and feline. So once you pass on through this embedding model, you get all these vector representations. You can do this with documents, you can do this with images. There are different embedding models for different things, but you can pass all of those things through this. And as I said, these are like the vectors, the object, and as the vectors you can see. And if I just put this vector representation, the big array, on like a multi-dimensional space, so it will like plot something like this, because it's a big array and these are basically like points on multi-dimensional space. So now what does this represent? So let's say there are a lot of words, like as I said, man, woman, all of those things, and it got like pointed out on that map, right? Now let's say somebody asks like what is Web3? Okay, so we will convert that what is Web3 line into uh, the vector representation, plot it, like just for how it works and how we think about it. When we plot it, we will find, okay, give me like 10 or 20 words which are close to it. So let's say the point is like somewhere, uh, like at some place. So all the points, all the sentences which are very close to this point, so that will be picked, and that is how like you use embedding models to find out which are like the related sentences, which are the related words for giving context to LLMs, and so that they can answer. And that is what behind the scenes LLMs also use embedding models. Not only like LLMs and chat GPTs and all of those things, this has been used by Netflix also. So the chat, the recommendations you get for like videos and all of those things. So they use this embeddings and embeddings model itself. So whatever you do, whatever the actions you perform on their app, they convert into vector representation, your interest and everything. And then whatever the content they have, they just basically map, okay, which are the related things this user wants, and they find out from like finding out the nearest things in their content and all of those things and present to you. So this is what embedding model means and what this embedding means, and this is very important. We will just come to this in a bit. Now let's come to like the next thing, which is called RAG, retrieval augmented generation. And this is what AI agents are built on. Is this is what exactly you have to do if you have to build AI agents. You have to build a RAG. And what RAG means, uh, let's talk about that and how that works. So you probably would have, if you have interacted with Chat GPT or Claude or any kind of LLMs, you would have seen, if you have asked some question to it, let's say, give me this code in the starting, okay? So give me this code, or if you have asked any question, it will answer you perfectly in the first iteration. But once you like talk for a long time, after some time it starts hallucinating and start giving you wrong answers, right? You would probably have seen this in chat gpt and stuff. So if you have like said a lot of things in the starting, and let's say after 1 hour of continuously talking to it, if you ask the same thing again, it will not reply you back with that information, because chat gpt doesn't have a lot of memory, okay? The context window is very small, it cannot hold all of that information. And sometimes if you ask like something very new, which was not in the domain of the LLM, it will not be able to answer, right? If you ask what is my name, it will not answer you what is your name. If you tell him like my name is Mohit and my name is this thing, then it can tell you. And maybe after like 1 hour, 2 hours, it might forget that as well. So now, how to solve this? Because what AI agents do is like they perform actions on your behalf. Okay. Or maybe you want to build an agent which helps you with some documentation for your company. You want to build a agent which of course is like a Twitter agent which can post on your behalf. You just want to tell that LLM that this is my profile, this is my all of those things, and do this operation, like just tweet about me, tweet about my projects. So how you can feed all of this information to chat gpt? I'm talking chat gpt, it's basically LLM. Why I'm saying this, so that you can understand. So how you can feed all this information to chat gpt, so that uh, it is able to perform all of these actions. It can perform and fetch the relevant information or the up-to-date information that is present in the current time. So for that, we use RAG. We build AI agents. You can also say like RAG is a way to give a lot of memory to LLMs, because LLMs don't have like a lot of memory. They cannot store it. So it has brain, but memory is very like less. So RAG is a way to give it memory. So now let's say how this works now. So as I already said, you might ask a question, okay? Normally what happens, you ask question and it goes to LLM and it generates a response. Now what will happen and how we will modify this? All of these chat GPTs and LLMs have APIs. You can directly talk to LLMs. You don't have to always go to chat GPT. If you want to build something out of these LLM models, all of them have API keys, and you just have to call their API to get a response. So that is one thing. Now what I will do to, if I have to build this RAG, so instead of directly answering the question, what I will do, I will build this in any language. You can build it in Python, you can build it in JavaScript, any kind of language. You just have to write code, simple code. Before like making the API call to the LLM, we will perform a lot of things in between. So what we will do, we will first take out the question. Okay, that is one thing. Before that, another thing that you have to do is, let's say you want to build, if I have to take an example here, let's say you want to build a documentation agent for your company. So you want to feed chat GPT with all the documentation that you have, and so that it can answer people with all of the questions, whatever the user asks in layman terms or anything, it can answer it back. So how you will do this? So you will first of all break down your documentation. Let's say it's in PDF or whatever website or whatever it is. You will break that data into chunks because you don't want to feed everything. And this is very important part of RAG. So the way you do chunking, okay, so let's say if you have code, if you want to feed code, you cannot chunk it like line by line, because it will just basically have like, in first line it will just break at function, next line it will be parenthesis, third line it will be another parenthesis. That will not work. So chunking is like very important when you are building RAG applications. So it is not always you should do by line, but this is a documentation. Okay, this is a PDF documentation, it has a lot of lines. So it is good to have like you break it down by line. So what I will do, I will break this data into chunks line by line, and I will pass it to the embedding model, all of that data that is present in that. Okay, and I will create the embeddings of this data and store it in a database. So normal databases will not work. Here we have to use vector databases. So if anyone have heard about this thing or just got to know about vector databases, so vector database is used for this purpose only, to store this embeddings, that long vectors. It's not feasible to store these long vectors, these long arrays and stuff in normal databases. So now every database have like either an extension that you can attach. Let's say Postgres has PG vector extension, so that you can store this data in Postgres and all of those things. Otherwise, there are a lot of databases which just caters to embeddings, and they also provide you with algorithms to easily search. Okay, like the same way SQL was there, you can have like these vector databases, and it will help you to easily find out like search from your database and find out which are the related words. So what I will do, I will just break down it in chunks and then store it in the vector databases after passing through embedding model. So in database, how I will be storing this, it will be like uh, the sentence, the full sentence, and the vector representation. Okay, full sentence and the vector representation. And now what will happen whenever this RAG will work? Now, how I have to write code is basically, from the interface, when user asks the question, I will first go to this code and retrieve what are the related sentences with respect to this question that is asked. So I will convert that question also into vector representation through embedding model, and then I will just perform a query on the vector database. So these vector databases have all those algorithms. So what it will do, because of embedding and all of those things, it will be very fast, it will be efficient to find out, okay, this person has asked question about this line of the documentation. User can ask anything and it will retrieve everything out of that uh, database, all of those sentences. You can have 10 sentences, you can have 20 sentences. That depends upon how you have built your RAG. Okay, and now that is like what the context is. So all of those sentences and the user's questions, I will just uh, I will not pass like just the question to the LLM. Now I will just create a prompt. Prompt just means like the question as well as some extra information or whatever you want. Okay. So I will just attach the context, the data, the documentation things that I have retrieved with respect to this question. Uh, both of these things will be attached and pass on to the LLM. And now the LLM will be able to answer because LLM has brain. It has now the information of your documentation, the related things. You are not feeding all the documentation because that is not valid thing, right? Now, if you have very big documentation, that is not the right thing. That is why we are using embeddings and all of those things to cut down and find out the relevant information only. And once this is done, once I call the LLM, it will basically create a response. And this is what RAG is. This is like the simple RAG that I have shown. You can make it more complicated. People use memory as well. You will attach your previous conversations as well. Okay. So whatever the questions that is being asked to your RAG, I mean to your AI agent, you will keep storing the questions that user has asked or whatever the information he has shared. You will also create the embeddings of that. You will store that in, and later on, whenever you have to answer the question, you will find from whole database. It depends upon how you basically put all of those things in place, but that is how it works. And then there is another thing you can attach to LLMs is called like tools, tool calls, or external integrations. So if your AI agents, apart from documentation, let's say there is another AI agent which wants to get like the weather data, or you want to perform a transaction on blockchain. Okay, in like crypto, in Web3, we are building a lot of crypto AI agents which can do transactions on your behalf, which can handle your trading things. Okay, so I was also working on something called as like a trading bot which can automatically close your positions and everything, can find out which tokens are best and can trade on users behalf while like user is also sleeping. Okay, so for that you need to have an external integration so that it can talk to the blockchain, it can talk uh, to the these APIs and stuff, and LLMs support this nowadays. Like OpenAI, Claude has launched like MCP servers. Claude Anthropic has launched like MCP server, which is a way to talk to external things, APIs and stuff. The before that, all of these SDKs which I will be talking about, they have a way to tell you. You can tell your like AI agent, your LLM, that these are the functions available for you to perform these actions. So how it works behind the scenes is like in the prompting, you can tell LLM like here is the user question, okay, here is the context, and here are the functions for you which you can call, and basically you can use these functions, these API calls to basically get the information to you. LLM doesn't make API calls as of now, although like now Anthropic and all of those things are doing this. LLM doesn't make directly these API calls. You LLM just generates the input for that function call. Okay, so if you write a JavaScript function and the JavaScript function is about getting weather data, so input will be the string, the city name or the country name. So you just tell the LLM, like when you chat, if I just say in layman things, when you are chatting and stuff, you can just tell it to have this function which is like get weather data. It needs an input of uh, this thing called as city name or this thing. And if you want to get the weather data, you need to perform this, you need to call this function. So now as LLM has the capability to think and decide. So if user asks what is the weather of USA, what is the weather of this place, so as the LLM knows that he has a function to get the weather data and he's able to think, he's able to decide, he will decide, okay, I need to call the get weather data function. Okay. And what is the city name? Based on the user's chat, the question asked, the name is like US and whatever the country is, and it will just basically make the call. Of course, behind the scenes, there are a lot of things happening. It's not a direct API call that the LLM makes. Okay. It is through the prompting and the step instructions and all of those things. But in general, I just want to tell you can just connect your LLM by building this whole structure, and you can just convert into an agent which can basically store things which have a memory because you're attaching a database. Okay. You can attach it to like the external integrations like APIs, to the functions, whatever the functions you have built. You can connect it to blockchain, you can connect it to any kind of things, and this is what an agent is called. And that is like the fourth point that I have already talked: AI agents and frameworks. So you don't have to do all of those things like yourself. Nowadays, a lot of companies are building these AI SDKs and frameworks. So they are making it very easy for users to uh, have this RAG built in, and you just have to plug things. If you want to create a Twitter agent, you can do that. If you want to do this thing, it's same as like you don't have to write HTML, CSS yourself. There are now React frameworks and all of those kind of frameworks which does the task for you, right? So they are just creating the abstraction. Of course, you can build the RAG yourself. Okay, but not everyone wants to do that. If someone is not a developer, they don't have to do that. They can just clone a framework. There are instructions how you can uh, put the things, and your bot is ready. But of course, for developers, you can do a lot more things. And if I just talk about the frameworks that I like, of course, there are like a lot of frameworks available in the market. But the frameworks that I heavily use and a lot of people actually heavily use is like, first is like AI SDK by Versal. Okay, this is like highly used. Uh, uh, I would say the framework. This is very lightweight, very fast. A lot of frameworks, for example, Eliza OS, are built on top of AI SDK itself. Okay, so there are like first level abstraction libraries, then there are like second level and third level abstraction libraries. One is like totally abstracting everything from you. So I will show that the Eliza OS framework that just abstracts everything from you, and it is just very quick for you to just tweak some settings and your AI agent is ready. But if you want to build something yourself and all of those things, you can use AI SDK by Versal. And the other thing is like LangChain. So LangChain is a bit complex, and it works very well for like complex projects. Uh, but it's not very easy to like understand and start working like next day. If you are just starting with building RAG yourself and all of those things, you can start with AI SDK. If you want to go a more in depth, you can use LangChain. And if you just don't want it, and if you just want to create a bot, and not only that, like you can change in Eliza OS as well. But Eliza OS is a way for non-developers to quickly put up your agents. And if you're a developer as well, you can tweak it very easily, and you can just customize it using plugins and stuff, and your AI agent will be ready. So uh, let's talk about Eliza OS framework and the character file. So if I just want to show before that like an AI Versal SDK's uh, example of examples. So yeah, sure. See, co-pilot is like I would say a lot of people ask this questions. They ask about like a bot. They specifically ask about what is the difference between a bot and an AI agent. I would say your question is exactly the same. So when you were building bot, you were providing it instructions that, of course, you were adding NLP and all of those things, but it was like within a thing, within like the information that you have provided and the instructions you have provided, that if a user asks this thing, you will perform this thing. Okay, if a user asks this thing, you will perform this thing. And on the basis of NLP, it was able to give you the answers it was able to understand the questions, but it was not able to give the answers in a large domain, right? It was just like, okay, I want to book a ticket. Okay, sorry, there are 4 options, right? It was limited. But now AI agents, what are you doing? Like the main difference is you are giving the brain to the bot. That's the main difference. Initially, those bots were code. Okay, still it's code, but those bots were like just the instructions that you have given, that if user does this thing, like Telegram bots. So if user perform this step, if you are asking, like if he's clicking on this button, a set of things, and it is able to answer it. But now you are giving it the brain to think, understand, and like take actions based on conversations. Okay, so I would say that is the main difference between like a bot, a co-pilot, and like the AI agents. And AI agents, like of course, it's, as I said, it's the same kind of thing. Like you are integrating with external integrations. But if I just show you as well here, like I will just show you an image generation thing. So it will think and call an action to do something. So just a second. I think just I have to take out the HDMI. Is it fine? Yeah. So this is an example of AI versus SDK. I will just give a quick example of this framework. So let's say you want to talk to OpenAI LLM and all of those things. Okay. So it provides just like very simple functions in JavaScript. You can do this in Python as well, and a lot of libraries as well. So what you do is like you just from the AI SDK, you just uh, like import OpenAI. Okay, there are a lot of functions called as stream text or generate text. These are the functions that you have to just call. You just provide like which model you want to use of OpenAI. Okay, the messages. Okay, so this messages you will take it from the API endpoint. So this is like I have created an API. Okay, a post API in which the user will ask the question, and once you ask the question, you will just put it this in function, and uh, that's it. If you just return it from like result.to data response, the user will get the response directly from the LLM. So you can just see like it's just this piece of code through which you are now connected to like the LLM, and it can respond to your questions. Now let's say you want to integrate it with the get weather data API and all of those things. There is something called as tools. You just have to put like here uh, tools. Okay, and you just have to define some tools, like let's say get weather data, and you just provide like get location, and you just put like whatever the data there is, right? So uh, uh, you just put like whatever the logic is there for like calling that API and all of those things in this function, and it's done. So this AI Versal SDK now will know like there are these tools available, which is called as get weather data, uh, or you can attach like any other tool as well. Like if you want to attach uh, a tool about like get my documentation, so you can just attach that and get my docs, use this, and that's it. So in this way, you can just attach like tools, and it can perform like whatever the task you want to do. If somebody asks like what is the weather, of this particular city and this thing, the the AI Versal SDK handles behind the scenes of putting these tools in the prompt, that you have these functions available for answering the user questions, and if user asks the questions with respect to these tools, it will call that function. So this is like very easy to understand thing, but we will go into like the framework called as Eliza OS for building a Twitter agent. So yeah. Oh, okay. String that. Okay, so let me talk about now the framework which is called as Eliza OS. So what it is and what exactly it does behind the scenes. So this framework is very popular in crypto industry. Okay, it has been popular outside of crypto industry as well, but it just like have been blown in the crypto stuff. So what they have did is like, this is a JavaScript based framework, an AI agent framework. Uh, they built the core modules of it, okay, and they just wrote everything, whatever I talked in RAG generation. So they just created the functions which basically talks to LLM. They created functions for embedding. They created functions for storing the data. So if I just go into like packages, and if I just go into like core, you will find out this is like the main uh, all the files of like Eliza OS. So you will find out they have written everything about generation, like image generation, text generation. These are the files you can say, like parsing, providers, RAG knowledge, runtime settings, memory, how to handle the messages, how to handle the knowledge. So they just created this whole thing that I talked about RAG. They packed it into this framework called as Eliza OS. I mean, like if you want to run this, if you want to create a bot using Eliza OS, you just have to clone this library. If you have laptops, you can try it now with me. You just have to clone this library, this repo, and then you just have to create a character file. Character file is just a JSON file. If I just show you how it looks like. So these are a lot of characters that I have built. So this is like a free character file like of my company. So okay. So I just created this character file which I just put up like what is the bio of this bot, okay, this AI agent, what is the lore of this agent, what is the knowledge of this agent. Knowledge means like what is like the data and the knowledge it has, documentation or whatever, how it should message people. Just few examples you have to give, like message examples, post examples. If you are building like Twitter bot and all of those things, you have to put like post examples and stuff, like how it should post, some examples of it, topics, styling of posts. These are like just textual data and stuff. That's it. And you just provide like on which clients you want to make it work. So I would say Twitter. So it will create a Twitter bot. If you want to like create a Telegram bot, you just mention that Telegram client. If you want to talk on like, if you want to create a bot which works on Discord, just mention Discord in the clients. And then you just have to provide the secrets for like talking to your, so that this bot can connect to the Twitter. So they don't use Twitter APIs. Okay, they use like the proxy login method, like the browser-based automated login methods. So for that they use like the library called as Twitter client, agent Twitter client. Okay, uh, and uh, you just have to provide this character file and run one command by cloning this repo, and your agent will be up on Twitter and it will start posting. And it is not like just whatever you have mentioned here, it will post that. No, it will think whatever the information you have provided, it will react on that. If somebody comments on your post, it will reply to that post. Okay. If somebody like ask a question by mentioning the Twitter bot, it will do that. So I have my Twitter profile also automated using this. A lot of people have automated using this framework. A lot of company has been like automating this thing. A lot of people have automated their Discord channels. So now if somebody asks questions about their product, so using Eliza OS framework, what they do is like they just set up this character file, and now the bot basically answers the user question. If somebody asks, I am stuck with the error uh, on your, when I was like attaching a domain to your website or whatever it is, and it will reply back. It will think, it will fetch from the documentation, and it will basically reply to that user. I mean, like in my company also, we have said this thing. So as I already said, the code base, if I just go a little bit more into like uh, the code of it, you don't have to go in like you don't have to understand this thing. If you are a developer and you want to tweak it with respect to what you want, because this is also a framework, then you need to understand where exactly the code is and how it works. So let's say all the logic of calling the APIs and everything is present in generation. And you can attach a lot of LLM models, not only OpenAI and these things. You can attach like Open Router, you can attach like uh, Google Gemini, whatever model you want. Of course, you can do that with a lot of frameworks. So, but if you just see uh, in this thing, like all the things are written here. Like if I just see like uh, stream text. So if I just search stream text, so you can see here it is creating the request body. Okay, and then it will be calling like the functions. So if I just call event stream, like on the endpoint of whatever the, let's say OpenAI and whatever the model is, it will call on that, and it is like abstracted over all the LLMs. So you don't have to like do it. If you want to change the LLM from OpenAI to Claude, just change the model naming character file that I want to use. Uh, like for example, here I have sent like the model provider that I want to use is OpenAI. But if I want to change it to like Anthropic, just write Anthropic. If you want to use Gemini, just put model provider as Gemini. And if I just show you, if I just run it, I have already like stored this thing. So this is my Twitter account. If I just show you, this is my Twitter account, the bot account. Okay, 2 hours before I was testing it, and this is my character file for it. I just have like cloned the repo. It will take some time if you are doing it live. So I have already done that. So if I just clone this repo and I just created this character file, I have already shown you. I have put the secrets. Please don't uh, take a photo of it. I mean, I will change it. Okay, so I have just like put the username, password, and this thing. And after that, I have just put like bio, lore, knowledge, and everything. Okay, just few examples. I just did like npm install. Okay, when I cloned this repo, so you just have to do like npm install to install like all the dependencies, and then npm build to like build the package. And once you are done with this, what I will do, I will just run this command npm start whatever the characters. You can build 2-3 agents, and you can provide the character files for all of it. If you want to run like 3-4 agents at the same time, just do like comma and another character file path. So this is like present, this fleet.character.json is present in my like characters folder. So I will just start it. So you will see it will just load everything. It will load the Twitter client just in a moment. And yeah, so it is loading based on whatever the settings and everything that I have set. Just like perform few things. Whatever the knowledge that I have provided, it will create a database. It is using SQLite database as of now. So it will just like, so you can see it just logged into the Twitter. So how it is talking to the Twitter, I will just show you in a minute, but it just logged into the Twitter account and have started generating a post because I had said like post immediately. So if I just go on my bot, so you can see just 15 seconds before it just tweeted something, building the future of decentralized app. I mean, I have not provided this thing, it just randomly generated. And how it just basically randomly generates it, there is a time frame set like between 150 to 200 minutes. So you can tweak these settings. There are a lot of settings that you can tweak. So you can just put like after every 1 hour, post a tweet. I have done this on my account as well. Just post tweet after every like 4 hours, and based on my character file, it generates like very good tweets based on what I want, because I don't have time to operate my Twitter account all the time, and I don't want my engagement to go down. So it just posted it. Let's say if I like comment something from my another account, my main account, so and talk to this Twitter account, I can mention that as well. So if I just comment like, hi, what exactly Fleet does. So in some time, it is like continuously checking uh, whatever the interactions that are happening on the Twitter, and in just few minutes, like after every check, it will basically see that comment and will basically see. I think it has seen that uh, text, whatever the comment I have done, and it basically talked to GPT-4, and I think it has created the response, and possibly it would have like commented back on the Twitter. And also you can see like it is writing that executing handle for action continue. There was no action performed. If I would have asked like create an image, then it will go to a image generation plugin or image generation action, and it will just basically do that and create an image for me and return it. I will show you that as well. That is called as tools, like talking to the external world and talking to the tools. But here I just ask a question, and based on the context that is provided in the character file, it generated the response. If I just go back, and I think I have got the response. So yeah, I got the response from the bot. So I had asked what exactly Fleek does. So it understood the question and just responded it. Fleek is like the Swiss Army knife of Web3 and decentralized app hosting. And then, I mean, it created threads as well. So it might create a long answer if you ask a long question. If you ask about a code thing or like whatever the thing you want, it will generate that. Let's say I just tag this coder test ACC. I mean, already there is like an image generation action attached to it. Can you generate an image of dog? So if I just post it, so probably it should pick. Although the character file is based on Fleek, okay, it got the message, and I think it would have replied, okay, it took the action of generate image. So you can see, I had asked this time, I want to get an image, and it found an action. I will just show you in a bit like where this action is present and how it is picking this. But It just took the action, generate image, generated it, is using the image model provider, and will reply with an image on the Twitter. I think it should have replied by this time. Uh, Let me go on profile. I had asked this question. Yeah, it created an image of dog. Of course, it's like not the best. You have to tweak the settings according to what kind of images you want. But you can see you can create these kind of bots very quickly, and this is what is called as AI agent. Because in character file, I have not told that you have to put like you are an image generating bot. If somebody asks this question, then it will answer no. I just provided about Fleek, but I just added a capability to generate an image as well in the form of actions. Okay, and just adding that action, the model is able to think and decide, okay, this person has asked me an image, so let's find out if there is an action. Okay, I have an action of generate image, use that function call and reply back. If I just go into the code, like where all of those things are there in Eliza OS, what you can do is basically you can have plugins and you can attach a lot of things. So everything is plugin based. So if you go in like the client Twitter, so there would be like this is the client Twitter. All the logic of posting is present in this code. You can tweak it if you are a developer. You don't have to tweak it if you are not a developer. So everything is there. You can see the prompt is written here. So whatever the prompt that I have told you about in the RAG, it is here, like area of expertise. From the character file, I am taking the knowledge. Okay, about the agent name, okay, the bio law topics, everything is present here. Then what is the task? This is how the prompt is written. Like generate a post in the voice and style perspective of agent. This is a Twitter name, write a post about this thing. You can tweak it according to your needs, but this is what I was talking about. Question plus context plus actions and all of those things. Then you make the LLM call. That's it. This is called as RAG. And I have just, there is just like the guidelines put and everything is there. And then there is like the logic to connect to the Twitter. Okay. And if you talk about the plugin generation, like how it was able to generate the image. So there is like image generation plugin. And if you just see there is an action, if I just go down, so there is like this, I have created generate images plugin. Okay, this is basically an action. So you can see in actions, I have just defined the image generation. Okay, and if I just go in like in the plugin itself, all the details are there. Like in action code, everything is written, like how to connect to it, how to handle this thing, and all of those things. As the time is less, I mean, here also there is an image prompt and everything. So you can just go on the repo and try it. But uh, yeah, I will just take in a bit. Yeah. So this was about Eliza OS framework. Okay. And at the last, I would say how Fleek can help here, like why Fleek. Okay. Uh, because we are all into this thing. So you don't, if you are a non-developer, you don't have to clone this repo as well. You don't have to do it. You can just go on Fleek XYZ. Okay. And if you want to deploy an agent, okay, you can just upload a character file here. You don't have to put anything for like the infrastructure, AWS, and all of those things. You can just put like character file here. You can build from scratch. We will just ask questions here, and otherwise, like you just upload the character file. I have already done this, and we are like also doing it for B2B businesses as well. So if anyone wants to build on top of us and wants to use our infrastructure, they can do it. They can do it very quickly. And I think it's very easy. You can just try it out on like fleek.xyz. Eliza, I think the time is less. Just a quick 1 minute thing, like what is the difference? If you are deploying on Fleek, in just 1 minute, your Eliza will be up with everything. Like on the server and stuff. The cost is just $20 per month. So it's like if you are deploying on AWS, you have to maintain everything and stuff. And the best part is like we are trusted execution environment. Okay. So if you want to check, because agents pose your knowledge, they have the credentials, they have the everything. So it should run in like in a very good, uh, like in a trusted environment, so that the servers cannot access all of those things. So we have this trusted execution environment, and you can do all of those things. Whatever the code you are running, you can check whether it's running correctly or not. Is the exact code that you were running, and if your credentials are safe, you can do all of those things on our server, and you can definitely try this out. So this was uh, all about the today's session. Of course, you can go on like geek.xyz Eliza, as well as on the Eliza GitHub to look into the code and everything to build your own agent. So it's just building a character file. Yeah, thank you. If you have any questions, I mean the time is up, but if you have just any questions, yeah.
Yeah, that's a good question. Where can we find good examples for character sheets? What would you advise?
So I would say like for the Git for character sheets, you can use AI models for the first hand itself, like to generate a character file for you. There is no like a repo where everything is present. There is nothing like that. But we are also building a framework which can help you to create character files as well, in just asking the questions and stuff. But I would say use, because character file is something that you have to modify, because that is how you have to provide context. You cannot automate everything, and maybe your bot will not be perfect. So there is no example. Yeah.
You mentioned early on that LLMs can update API calls.
Yeah.
Is that changing with Menace? In Menace, do that? 'Cause I've seen that.
Yeah, MCP is also doing it. I mean, like the Claude, Anthropic. Then, if you have heard about the MCP server, so I mean, it's again not exactly the LLM is making a call, but they have built the backend stuff like that so that they can call and they can connect these external functions or the APIs to the app, which is like interacting with this with the user. So now Claude can connect to these servers, the Claude desktop, and all of those things, and it can call those functions. So, but of course, like a lot of other LLMs, like you said, I have not tried that, but uh, we are also partnering with one LLM, and they are also working on like direct API calls as well. But models cannot do it. The surrounding infra can do that.
Okay, so
Yeah.
we've run out of time. So if
Yeah.
any questions,
Yeah, you can go. Thank you.
thank you. For
So, Fake is a paid service, right? Not really open source.
No, but we are a partner. We are a partner of Eliza OS, so that is open source.
I see.
We are the infra. So if you want to use for infra, Fake is there. But if you want to use, if you want to deploy your own thing, so Eliza is open source.
I see. So we can just like clone that repo somehow, use it, but somehow it's still missing something, right? It's still missing the infra.
Yeah, I mean you have to deploy it because it's an agent, right? It's a you can say an SDK framework. So you have to deploy it somewhere. But for that you can use Fleek, because for agents, trusted execution is very important.
So on top of the cost of fleet monthly,
Hmm.
we also have to pay for like let's say whatever LM we're using, or is this include fleet already?
Currently, you have to attach your own API key, but we are launching another version where it would be just $30 or $25, and we'll handle your LLM as well, the APIs and stuff.
I see. So it will be like let's say also with the included monthly subscription to whatever bunch of LMs, right?
Yeah, you have to like pay for that the LLM calls, because that is,
Just
no, you have to attach your own API key.
Do you know when the rollout will be?
The open, I think in just next week.
That's
Yeah.
because all the different like expenses can compound really fast.
Yes, exactly. I understand that.
And if somebody's already paying for like the ChatGPT Pro, and maybe in the future ChatGPT Ultra,
Yeah,
AI Plus,
exactly, exactly. So we are like, I think it's already like in a staging environment. In next 1 week, it will be like live. Yeah.
I guess you have Talisman.
I have.
Talisman.
Oh,
Thank you so much. Thank you. Where's the feedback from? Of course, this is for the recording. Um, okay, welcome back. So we have the next session for this afternoon by Michael Christian. Did I pronounce it right? So Michael Christian is a long-time open source developer. With over 20 years of experience building tools for the FOSS community. As a maintainer of YACY.net, a decentralized search engine, and Suzy.ai, an open source conversational AI, he cares about open knowledge and DIY tech. And this afternoon, he'll be talking all about ChatGPT.
stock changes and we have new markets. Chen, and he introduced he was thinking about a way to win with roulette. So he wanted to compute how the stream of numbers, the stream of numbers that appeared at roulette. So he computed the likelihood as well, and he found out if it's possible and Martin Minsky wrote a book about the perceptron and proved that it's not useful for anything. So a long time went by until someone else, we will see, discovered how to do this actually in a good way. At this time, there was already a discussion about what is artificial intelligence, can artificial intelligence think, is it able to understand, and so on. And philosopher John Searle introduced the idea of the Chinese room. It's a little bit strange to present the Chinese room in Asia, but that's what he called it. He said an artificial intelligence is something like a room where I pass in a letter full of strange symbols. Let's say they are Chinese symbols. And then this room is full of books, and there's an operator who reads the books and has some instructions what to do with all these strange symbols, and all these books show him that he has to put in some other strange symbols, and he passes this out, and then what he passes out is a message which actually makes sense. But he says, the person in the room doesn't understand anything of what he did in the room. He was just organizing these books, and the person didn't understand anything about this. Therefore, the whole machine, the room, doesn't understand anything. I think this is a very strange argument because, in my point of view, it could be possible that the room has understanding about the operator, but at this time, nobody was thinking about this. But I think it's a very good example to describe how LLMs work. We will see, we will use this argument later. Now, we have Geoffrey Hinton. And Geoffrey Hinton got the Nobel Prize last year, not especially for neural networks as he did it, and the work he did with back propagation, but he did something before which was actually related to physics, and therefore the Physics Nobel Prize was appropriate. You can think about this in a different way if you're a physicist, but what he picked up was the blood, and he introduced a mechanism that was not only able to compute everything that the perceptron wasn't able, but he introduced also a learning process so that the network was able to learn to perform a specific task. He also introduced the autoencoder, which is a special topology in a neural network. If you make a small section in the network, then the network is forced to do an abstraction there. So therefore, he found a way that the neural network is not only performing a computation, but is also able to do an abstraction of the actual task. So if we want to go forward, we have to think about some mathematics. We need a little bit of linear algebra, and most of you should have linear algebra in school. So everything which is on this slide, you should know everything of this. I don't expect that you know what's a vector, what's a matrix, how to multiply a matrix, but I just want to keep it in mind because there's something very special about the dot product or the scalar product. This is an important thing. The scalar product is computed by multiplying some two vectors, and it gives you the cosinus distance between those vectors. That means, are these vectors orthogonal to each other? Then the product is 0, and
also bias and activation function. The activation function makes this nonlinear. The activation function must be a nonlinear function. And so you don't need this handy anymore. It's only linear algebra. What we are doing is static multiplication, and you can write this in a very short form. And that's the form we want to use further on. So if you want to do an inference, then you just have to do the calculation for
likelihood that the special event happens. Like this is 10% likelihood, it's 27% likelihood, it's frequent likelihood, and if you compute the sum of it, then you have always one. Activation function you can use everywhere in the talk. So, 1996, a student from Schmidt-Huber, Sepp Hochreiter, wrote a master thesis where he had a strange idea that he wants to feed in the output of a network to the input again. So it creates a recurrent neural network. It's moving into a loop, and what it introduces is some kind of memory. This kind of network has a memory of signals it has seen before, because it computes depending on the signal before. And both did some research and found out that there are some problems to solve, like the mentioned problem, and what came out was the LSTM, long short jump memory, which is something that was used the next 20 years. It's still relevant. It is what enabled many companies, large companies, to train networks that have been able to do translations, for example. And this was the major breakthrough which introduced the computation of sequences with neural networks. So next thing that happened was convolutional networks. What we see here is a very young Jan person here, who puts a paper under the camera, and the computer recognizes the numbers and shows this. Jan is a student from Geoffrey Hinton, and he did more research, and he developed convolutional networks, which is a special shape of a neural networks, which is able to do pattern recognition. And then 2017, I think, he was asked by Mark Zuckerberg if he wants to start a science department at Facebook. And he said yes, but only if everything that we produce will be open source. So this is a major point, because we have seen the first large language models coming from Meta, and maybe because he got this position. Oh, I don't have this slide here. Okay, because he got the position because he said everything must be open source. Maybe that was the reason he got large language models. Next is Joshua Bengio, and I think Bengio should have got the Nobel Prize for what he did, because he said if we want to put in characters in the streams that we want to predict, then they must have some meaning, and therefore we don't put in characters, because characters don't have an inner meaning. You need something that has an inner meaning, so we do a tokenization. We say some words can have assigned meanings, and so we first make words out of the text, and then we identify meaning of these words. But how do we create these meanings? And these are the embeddings. So I made an example for the embeddings. I have three groups of text. Of words. I have vegetables, I have emotions, and I have operation systems. So operation systems, I have many more, but in a high-dimensional space, they create groups to each other because they belong to each other, because they have similar meanings. And I don't have a high-dimensional room here. I have only a 3 dimensions, so you can think of a cube, and in every corner of that cube are groups like emotions, vegetables, and operation systems, and they don't have anything to do with each other. So if you would compute the cosinus distance, the cosinus distance would be 0 because they are optimal to each other. The one exception I have taken the word fun and moved it a little bit along to the operation system dimension. So fun and Linux operation systems have something in common. That's what it expressed. And the cosinus distance is not 0. So if you want to do this with a large amount of tokens, you need more dimensions because the dimensions have all some kind of meanings. So 2012, we see Geoffrey Hinton here, and on the left side, Elias Hatzgeber. Elias Hatzgeber was went later to Google, and when he was at Google, he was asked by Elon Musk if he wants to be a part of the foundation of OpenAI. He said yes. So I think he's the one who created ChatGPT in the core team. There are other people who have contributed, but I think he's a key position in this. And this team had the first was the team that had the idea first to use GPUs for computation. So this is another milestone, and it's kind of a family. Geoffrey Hinton, all the students from Geoffrey Hinton have been contributed to this research. So now we come to the attention mechanism. Then the attention mechanism was invented. It wasn't called it really in that paper. The word attention appears just at one single position, but the attention mechanism was applied to recurrent neural networks, the Schmidt-Huber LSTMs, and it works like this. So, you create something that is called an encoder-decoder. And the idea is that you have two streams. One stream is creating tokens. Another stream is influencing the creation of tokens. The encoder has a token sequence with text in French language, and the decoder starts with the start token and is supposed to create tokens that are created because they are influenced by the encoder part. And that part which is doing the influencing is this box here. And this is called the attention mechanism, which is kind of the idea that you have two streams of context, and they overlap in some way, and they tell each other how to influence each other. We will see this in detail how it works. So at the bottom here, we have RNNs like LSTMs, and they're creating the token stream. And what happened in 2015 was that at Google they found out that these LSTMs here have they need a lot of computation to be trained, and another mechanism could replace them by using the attention mechanism in a special way, which is called self-attention. So you replace these RNNs with self-attention mechanisms, where a stream is influencing itself. So this influence from one stream to another can be used by using the same input. A stream that is influencing each other creates memory of the past of the stream. You will see how it works in detail. So therefore, these kind of encoder-decoder constructions don't need LSTMs anymore. Everything is attention, and therefore the paper was called attention is all you need, and it's not showing them. So attention was the name of the paper. So you always see this picture. That's the encoder, that's the decoder. And next thing what happens was that people at OpenAI, they have been working on games so far. And they took this thing and said, wouldn't it be interesting if we omit the input encoder? If we just take this away, we don't use it. We just create. Yeah, this is the encoder-decoder construction, and we just don't use this anymore. We just use the decoder. So this is the construction of a generative pre-trained transformer, GPT. So how does it work? if we feed in here something, then what we feed in are tokens. And we have here an example. I used the example sentence, the inmost force which binds the world. So if I tokenize them, I can see the colors, which kind of tokens that are, and every token has a number, and these numbers are fed in here, and they are in the beginning translated to embeddings. So left side, this is part of the code from GPT, which GPT-2 is open source. We see that these models have some attributes, they have numbers, and we can see that these decoders, they have many layers. In this case, they have 12 layers, they are 12 times. Then we have the a number like a D model, which is the multi-dimension of the embedding. And this is what the transformer does. It takes a token like force, it has the number 2700, and it goes into a small neural network which computes the embedding. It says, okay, the token with the ID 2700, it's like a lookup table, has a specific embedding. And the embedding is has a dimensionality of the D model value. So the vector has 1536 numbers. So this is a vector with the dimension 1536. And the word force is translated into all these dimensions, which have some attributes which create a meaning of force. So it's the fourth token, and the fourth token goes into position 4 in the token position. So then this yellow box is represents the context window of the model. The next thing that happens is a positional encoding. Positional encoding is a strange thing. It assigns every embedding an added value, and that added value shows the model that it is at a specific position in the context. And this positional encoding is a number that is pre-computed. It's always the same. It's just added to the context every time, and it's like a wobbling around the position. The wobbling around the position gives the position in the context depth. So what we have at the end is an encoded representation context. So we go from the encoded representations with the position encoding at the beginning, and what we want to have at the end of the transformer is computed encoded representation at the generation level end of the model. And what we know from the output, all the Zn 0 to 6 are the words from the input. We know this. If the same output comes out, we have the input. But what we don't know is one token that has to be computed. And therefore, the end of the computation of the transformer computation is only one token. We read out only one token, and that's the completion of the sequence, the inmost force which binds the word. Okay? So now something magical must be there in the middle. How do we get from left to right? And I think the best representation is the Chinese moon. So these are these magical symbols which reach a kind of room, something happens, and we get a new token. So you can think of kind of magical books here that are used in some way. They are applied to the context, and it creates this output. So what are these magical books made of? How are they created? So let's consider we have two contexts. We have two contexts called Q and K. And you can imagine that Q is a text and K is a text. So you would ask yourself, okay, but if I want to learn something from these two texts, then, for example, I could ask myself, how is one word in one text related to another? Okay, where are words which have specific meaning? So we can have a kind of lookup table which expresses, okay, these texts have something in common, and they have something in common at specific places. So we must remember that every row is a vector. Every row is a vector. And they are matrices. So if I want to combine these two matrices into a meaning representation, I I turn the matrix K and multiply row with column. Okay. So if I multiply the row with the column, then I have the combination of the first row and the second row of the context K. And because the multiplication of Q0 and K0 is the dot product. So the dot product of these two vectors represent how much these embeddings have in common. Because I get the cosinus distance of these both embeddings. Okay? Because KT is the transpose matrix. Therefore, the row and column are the dot product. Okay? So what I get out of this multiplication is a new matrix which has a relation expression between all these positions in the text. And because I like the softmax activation on top of it, I also compute the likelihood that one of these words has something in common with the other text. And square root of decay is a normalization of the multiplication. So the softmax works better. Now I have another context V. And another context V is another text where I say, okay, I have this combination of these two texts. I have likelihoods how these words are related to each other. And they are like a lookup table to say, from that other text, I take some embeddings and use them. Okay? So, if I want to learn something, I have to apply some weights. Because this is a learning system which applies some weights and say, this relation is something valid, and sometimes it's not valid. I need another matrix which expresses that a text has some valid relations between tokens and other ones don't have this. So these gray boxes are these weight matrices. And what I do in self-attention is that all of them, all of these Q, K, and D is the same context. So I multiply a context with the transposed version of the same context. I get a relational matrix and apply this on the same context. That's self-attention. So, and on the left side, we have this magical books. They say, okay, you have some inputs, they relate to each other, therefore we select something from our whole set of possible tokens that we learned, expressed by this weight matrix, and use it as an output of that attention layer. Okay? So, what we also do is tear these matrices apart, because this allows us to do concurrent computation of parts of the matrix. This is called multi-head attention. I don't have only attention, I have multi-head attention. And this is done then combined with a combination matrix again. And this is our Chinese room. Here subscriber was asked, what do you wonder most about GPT? And he said that it works at all. So this is a machine which applies understanding using embeddings to a context, creating a new context. And this is one multi-head attention layer, but we have more. We have many of them. And this is just a picture of the thing. We have many more because we have in GPT-3 we have 96 of those layers, not 4. And we have 128 attention heads, not 6. It's a very large construction. And to be complete, this is not everything which is in between. We also have these feed-forward networks. These are the 2-layer networks which takes the output of the attention layer and produces another version of the context. The network needs this to be able to learn faster. So this is kind of what you say, we have abstraction, production, abstraction, production, abstraction, production 96 times. So this is the result. This is the graph from the paper. Attention is already reduced to the one input layer, and everything that happens in between is expressed by this one equation. What I made is just I try to visualize this. But what we need is the self-attention QKD product, and that's all which creates meaning inside of this chain of computation. So when they are trained, when these networks are trained, a very large amount of data are put inside. This is not the exact amount of data because it's not known, but in 3.5 or 3 was filled in. This is from a different model, GPT-J6B, a very old model, older than GPT-3, and they use, for example, the screen part is 20 biggest Wikipedias. OpenText2 and Pile, these are web crawls. Arxiv is all the scientific publications in mathematics, in physics, and other sciences, medical information, and so on. It's all of GitHub. Bibliothek is all of books. So yeah, there are numbers behind it, and you can take some parts of the data set and train it several times, and that's the training strategy that you apply. And this is a screenshot from the documentation of the OpenAI API, and they gave this example before GPT-3.5 was published. This was a way to use GPT-3. It was not used. It was not published to be a question answering machine. It was just something that can do a completion of text. And the example they gave was this: Q. What is human life expectancy in the United States? A. Yeah, you see this prefix Q, A. Human life expectancy in the United States. This is an example answer. Then two life weeks and then Q again. What is the meaning of life? And what they are doing here is they give a kind of example how text can be completed for the purpose to answer questions, because they give a structure to show how a question and an answer look like, and they show how a question looks like. And the next thing that the model does is, okay, it knows the next thing to do would be an A. Yeah? Not be an A, because this is an example. This is what the context in the self-attention is producing in this kind of multiplication tables. This relation is known from the current context. So this was called the one-shot prompt. And with the one-shot prompt, you have been able to create question answering machines before ChatGPT 3.5 was published. So you create maybe different styles. It's not necessary that you have a Q and an A. You can also say assistant, human, and so on. And this is a kind of few shot prompt. So you have several examples, and the model then answers very confident in the way that it creates an answer. So the idea was that these kind of one-shot or few-shot prompts are part of the training data. So in pre-training, you create a base model, which is like GPT-3, which doesn't know anything about questions and answers, but it can be fine-tuned using kind of question answering text set. And this text set must be of a good quality. It must show how to create quality kind of answers. And in reinforcement learning, the system is then forced to actually give answers, and some voters, human voters, decide if this was done in a good way or in a bad way, and this was then used again to train the model. So 2022, this caused publication of ChatGPT 3.5 as a fine-tuned model. Let's see. Okay. Here. Minkowski says.
Systems are designed in such a way that in principle, it knows nothing about language, learning, intelligence, thought, or none.
I idea that it's just exploiting the sense that's true.
So we have two opposite meanings about this. One Chomsky, which is a very important person in computer science because he created a basis for the theory of computability. The formal languages has a strong opinion, and we should consider this as very serious. If he says this is not intelligence, this is just pattern matching, this is just glorified autocomplete or glorified autofill. Why? Oh, again. So, this is glorified autofill. While Geoffrey Hinton says, okay, you can say this, but if you predict the next word in a good way, you have to understand the text. You need understanding. Ilya Sutskever made an example, said, if the document reads a story like a criminal story where the detective at the end says, and the murder is, if you want to autofill or autocomplete, then the name, you have to understand the story. This is not a simple task. So who is right? Because if you say Geoffrey Hinton is right, then this means these models actually understand meaning. So in the Sutskever, predicting next word in a text fishing web, we need to understand the text. Then we have Jan LeCun, who's we know, another student of Geoffrey Hinton. He says something else all the time, many times. He always says prediction is the essence of intelligence. Or the other way around, the essence of intelligence is the ability to predict. So if he if you put this together, you have the proposition of Shannon proved this in his work. He said compression is prediction. If you can compress, then you can predict, and the other way around. And we have prediction is intelligence, supported by Hinton and Satzgeber. We can combine this. This means compression is intelligence. And think about this. So a zip file is intelligent. Or maybe a LLM model file is nothing else than a zip file. It's compressed information. Is a zip file, has zip file understand many things in a special way. So there's a Hutter prize. The Hutter prize is a challenge where you get money if you compress a specific part. It's given. You can download this, a specific part of the Wikipedia, and if it's smaller than the previous winner, you get a part of these $100 million. And the idea is that at a certain point, you can only create smaller file if you understand the content of the Wikipedia. This compression contest, this is what Hutter provides on his page. This compression contest is motivated by the fact that being able to compress well is closely related to act intelligently. So this is an interesting thing, and there are many philosophical questions connected to this. This talk is not connected to it. It was just to discover this kind of question.
Well, isn't that specifically like, if you think about the way an autoencoder works, where you have smaller hidden layers and you're forcing it to compress, it's sort of making this manifest in a lot of ways.
In every layer, there must be some. It must make sense of something.
Right.
Like at the beginning of the layers, and you have different languages. They must all be transformed into an abstract construct which represents the meaning of the text in different languages. Because if it would only work for every language itself, it would be very inefficient. And the model wants to be efficient because otherwise it cannot be trained to a target where it works. So at a specific point of these layers, it has some understanding on an abstract level without languages. And then it picks things to relations. It's doing an abstraction of things, doing more abstractions represent the discovery of meaning. So if you do a constant abstraction to discover meaning, is this thinking? I can't answer this. It's just it's nice to discover these questions along the constructions of such fields. Probably in 5 years, something like a transformer doesn't exist anymore because there's something which is much more efficient. But, so you shouldn't say, okay, are humans just transformers? Because no. Right now, this is a good model, but you can have something else that's better. So these are the extra slides just to show what happens after ChatGPT 3.5. Only 1 month later, university said, okay, they created these large language models by creating these instruction sets. So let's create instruction sets by harvesting this out of ChatGPT. They created a lot of topics, they created artificial questions and answers, and they created artificial created instruction set which can be used to train your own language model, because base models have been known at this time, but not question answering models. And if this was possible, then Meta published that they are working on this. Only 2 months later, another month later, they provided some kind of base model for scientists, but they didn't think about a good publication way, and then there was in this repository a pull request saying save bandwidth by using a torrent to distribute more efficiently, which means you put this torrent in the pull request, and that was the Llama leak. That was the time where the first model available, first public available model was available for all people who wanted to use something like this, and then this instruction set was used to train question answer model, which was then called Alpaca, Stanford Alpaca. Yes. On some days later, and then there was an inference engine in C++ written. This was hacked in the evening. I have no idea if it works correctly. It is one of the most well-known inference engine that you can now run on the computer, and also on CPU works very well in the framework called Ulama. And tomorrow there's a talk. I give a talk. Yeah, show this how you can use this on your computer. And that's it. I hope this was understandable and sufficiently done, even if there are some magic parts, but even the scientists say it's magic and we wonder about it. So if you want to have the slides, go to my social media accounts and I posted the link to the slides. We have time for questions. Yes.
I have one question. So, if I am not mistaken, especially in the beginning of ChatGPT was bad at math, but it's basically all math. Why is it bad at math?
So math requires that you have some tokens which have meanings. So if you have just numbers, every number has a single embedding, and every other symbol that you need in math has its own symbol. If you don't have tokens on that can be assigned a meaning to it, then the learning doesn't work so well. Now the models can use better math because they are much bigger. This was a small model related to what's run today. Training data is much more, and yeah. But they still can do so good math. Yes, and can be much better. But on it's not a good representation on token level. They can do very well symbolic math, but not computation.
But it's still the same mechanism, even so it's better now. It's just bigger.
Yes. There are small modifications, but the principle is the same. Thank you. Yes.
Just kind of follow up. I was wondering if I should see if this region is which is if you just use ChatGPT, it becomes very obvious because you can just put these mathematics and I just won't be able to actually solve it. Doesn't prove that you really need.
Yes, it supports it, but it doesn't prove it. I would say, yeah, but it supports it, yes. Yes. And for Pomsky and for the next all right.
Can test. Okay. So how do I pronounce your name? Ilya. Swim lane. I go to books after this. Or this. And I will come back because I haven't eaten my lunch. Mute. Would you like to take a seat with this one?
Okay, so it shows,
Yep.
yeah,
Okay.
but it shows PowerPoint, not that you can use. Okay, that's, what? You need to show the screen, not the, oh, full screen. Yes. Because otherwise when you go full screen, it just keeps sharing the window. Okay, let's see if it's open.
No, good. Let's start. You will have 45 minutes.
People see it?
Yep. Is it okay? Good. All right. Okay, we are ready for our next session. Okay, we have Ilya Robitsky. He is a solution architect in the finance and e-commerce sector. Ilya gained 20 years of experience developing complex software in teams large and small. Before starting his business, he worked for several multinational companies in Europe, Southeast Asia, and North America. And today he'll be telling us how to unlock the power of graph databases with Neo4j.
Oh, is that right? I'm sorry.
Hi guys, thank you for coming to this presentation. Today we're going to talk about graphs and like what we can do with graphs and like how they could be useful. Our agenda for today, first talk about the theory and what Neo4j is. Then we will do some like, because I want to make a presentation more practical. So we're going to design a data model, review Northwind data model. It's one of the sample databases which was available for years. And after that, I will quickly show you how you can create your own Neo4j database, and then how you can deploy a model and do some cipher querying. Cipher is a language that Neo4j uses to query data. So let's get started. So graph theory started in the middle of 18th century by Leonard Euler, a famous Russian or like German mathematician. So we're still fighting. Was he a Russian or German? But anyway, so he lived in Königsberg. It's Kaliningrad nowadays. And he wanted to solve an interesting problem. So in Königsberg, you have a river and you had a few bridges. And Euler wanted to use a paper and draw lines through every single bridge without crossing it twice. And that's how we came to an idea. Okay, so let's do some mathematical representation of this model, and he invented graphs. So let's briefly talk about what graphs are. So basically, graph is a simple concept. You have edges, you have nodes, which is a point, and like the points have connections between them. So points usually known as vertices or nodes, and edges is just connection. So in earlier model, you had like points on the map, and bridge was an edge. There are two types of graphs. There are directional graphs, which means if you have point A and B, you can always go from point, let's say, A to B, but you cannot go back. And in unidirectional graphs, you can go back and forth. So let's see how like this simple theory could be used in our world nowadays. So graphs are used in multiple industries, like logistics uses a lot if you want to do like a transportation or like some like Google Maps, for example, you want to like create a route, you'll use graphs. In finance, we use graphs a lot when you do, so for example, you do like trade investigation or even like crime investigation. If you see, okay, where money came from, and if it's like a little thing. In cryptocurrency, graphs are used quite heavily for crime investigations, for example. In network in IT operations, it's used so use in, for example, if you have a network, enterprise network, you want to see, okay, how data is flowing through your network, what are firewall rules, etc. For example, I personally worked on a project where we built a model to predict potential data leakage and like data flows in network. So you have like enterprise network, and you can predict, okay, if there's a configuration mistake somewhere which we don't know. And last but not least, nowadays generative AI use graphs quite a lot. For example, if you use tools like Longchain, it has like native support for Neo4j. And the idea here is you have graph, and your Gen AI needs some data, some quality data, and your Neo4j, since it has information and relations between different informations, you can feed it into your Gen AI to produce better results. So why graph databases? Because we've been using relational databases for many years. But graph databases solve for one particular need. When you have hierarchical data, relational databases are pretty bad and pretty slow. And that's where graphs win. For example, if you want to represent a route, let's say a Bangkok roadmap. Of course, you can do it in a relational database, but if you try to build a route, it will be a very heavy query.
which is hard to debug, and probably it will take ages to come up with the result. And graphs can help to solve it. Also, graphs could be helpful when you try to find some hidden information inside your relationship. For example, you have your enterprise network, you load this data to a graph and start analyzing the graph, and you can at some point find out, oh, okay, we have like a subnet which no one uses at the moment, it's still there, but we never built like firewall rules, for example. Now Neo4j come to our play. Unfortunately, in graph space, there are not that many database vendors. Yes, like the theory about it and the technology was around for a while, but it's a very niche product. And Neo4j is probably like one of the best players, at least from what I personally tried. First of all, it's natively designed to work with graphs, and it's graph database. It's not like a MongoDB where you have documents, but they add more and more features on top of it. No, they precisely work on graphs. It's very, it has a good scalability, and it's a high performance database. It's fully ACID compliant, which is not the case for some non-relational, NoSQL databases. And yeah, it's open source. It's under GPL 3, and there's also a cloud version called Aurora. And in my opinion, if you want to quickly try or learn Neo4j, probably Aurora could be a good thing for you, because you can go to the cloud, create the free version of the database, load your data, and play around. Let's take a look what is a data model inside Neo4j. So in Neo4j, there are 4 major data elements: nodes, nodes, relations, labels, and properties. So node is actually data which is persisted in your database. For example, here I have 4 nodes, Bob, and like some of them like people, some of them are stations in London Tube. Relations are the links between those nodes. For example, here I have walk, ride, walk. Labels, there are different types of nodes. For example, in this system, we deal with people and with tube stations. So personal station, those are the labels. It's like a common tag for a particular subset of nodes, and each node could have multiple tags. And properties. In Neo4j, you can add additional metadata to nodes or to relations. That's how you can model very complex systems. For example, here you know, okay, we have a person Bob who lives near Bond Street, and if you want to go to Alice, he should walk for like half a mile. Okay, so I want to make this presentation kind of practical because when I learned Neo4j for myself, first I struggled with Cypher. And I personally like learning by example. That's why I took existing Northwind data model, which came originally from Microsoft, and it was developed for SQL Server. And then I took similar model in Neo4j and started to run queries. And that's why I want to show you how a particular SQL query, like starting from like simple queries, like more complicated ones, will translate into Cypher queries. So that's our model in SQL. So you can see we have a total joins, and that's how this model looks in graph. So basically, we have 5 labels here. So we have customers, orders, categories, suppliers, and products. And between those nodes, there are different type of connections. So in our case, customer purchases stuff. So customer creates orders, and which order contains of products. So that's how we link everything to each other. And instead of having all this like a heavy table implementations as a relational database, when you load Northwind into graph, it will look something like that. So you have several customers. For example, here our customer. Customer created like 5-7 orders, and then from each order we can see, okay, what products he purchased and who was the suppliers. Okay, so next I'll just briefly show you how you can set up a new database. You usually go to Neo4j and you create your account. Then it will ask you to create a new database. The process is simple. You just click create, and it will ask you, okay, you want to like paid version or free version. You choose free version, and after like a few minutes, you have your instance up and running. Then you need to restore the database. Northwind database, it's one of the samples which comes from Neo4j. There is a GitHub account where you can download like other samples. To restore, it's very simple. You just go to this web UI, click backup and restore, drag and drop your file, and after around like 10 minutes, since it's a free version, you will have your database. And that's how your admin panel or like a query environment looks like. Here you can see all possible nodes and all possible relations between nodes, and even the properties which you used either on relations or nodes. And then you have a query console. Okay, so let's start talking about Cypher. Cypher is a query language. There are like 2 or 3 different like, graph query languages available at the moment. And Cypher, if I'm not mistaken, was the first one, and it's the most popular one. For example, if you decide to go with AWS and use AWS Neptune, they will provide, like Cypher will be one of the options to use as a query language. And here it's a basic syntax. So you remember we have like nodes, labels, relationships, and attributes, and that's how you do. So nodes always in the parentheses, like here, for example, categories like our label. So this is some sort of syntax which we use. And the important thing when you define relations, you can query based on directional relations or like undirectional relations. So here at the top, you can see the difference. And from my experience, like from practical experience, try to use direction relationships as much as possible, because when you have like unidirectional relations, they're a bit slow, especially if you have like a large graph, it will slow you down. So let's compare SQL and Cypher. So that's a simple query, get all customers in SQL, simple. And on Cypher, so we use match statement. So match is it's a keyword, it's a Cypher clause similar to select. Then you say, okay, I want all nodes of label customer, and you always have to return something. So when you run it, it looks like this. When you use Neo4j environment, you can have multiple views. I found a graph, when you try to understand like how your graph looks like how your data is shaped, it's better to use graph representation, but try to limit the amount of nodes you draw, because if you can try to visualize like a crazy big graph, but then it's unreadable. You can also use like table representation. So table representation, it helps you to develop applications. So I'll show you next. Again, start simple. Again, I want to show customers, but this time I want to order them and get on it top 25. Select. Okay, in Cypher, we use order by syntax, similar to SQL, and limit. That's the way how you can do like pagination or limit the amount of data of your data output. Again, if you play around with visual graph representation, it's always helpful to use limit. Now, just to prove, I show you how the table representation looks like. So here, you see the underlying data structures which you will get if you query Cypher from like Python or from any other programming language. And yeah, so here you kind of prepare your query output to use in the application. Let's go next. Get orders from 1997. Yes, Northwind is old. It was popular till 2000, I think. Okay, simple SQL and match. So here we introduced where clause, which works similar to SQL. The important concept which I want to highlight here is this syntax. Because in SQL you have a field and it has a data type. Then you have functions which you can apply to your data and like year. In Cypher, you deal with objects. Date time, it's an object, and that's why in Cypher you can have like this object notation. So year is a field. So it's more like a object-oriented concept way of doing things. Okay, next one, get all placed orders. Simple query. There's not a difference between SQL and the Cypher. SQL understands date literals, so you can put your constants like this. In Cypher, since you deal with objects, datetime or date is an object. That's why you have to use this like a date constructor. So you say, okay, this is my date, which is a string. Let's parse it and create a date object, and then execute query. Okay, so next, create reports for all orders. Now we start to use joins. Here we join orders and customers and try to find the information. In Cypher, we don't have joins. We use relationships between nodes. So here we say, okay, we have customer, and we know that customer, this is a purchased relationship between customers and orders. And we just say, hey, Neo4j, please give us a subgraph of our customers and all linked orders. And then, then we apply where clause, okay, for this year, and then return P. This is like a strange syntax. So when you do match clause, you always have to return something. If you write like a P equals and then your expression, it's like a shortcut to say, okay, I want to get all output from this expression. If you don't use this annotation, you have to provide, okay, I want to do like C or. So it's like a shortcut. Okay, now it's more interesting. So we are going to get a report of customers. So now we have select. We don't want to return everything. We want to return only particular fields. Here, Cypher is similar to SQL. We just provide in your output, instead of saying return P, return everything, you just say, okay, please give me only a particular subset of information I want. Okay, let's see how we can use aggregation. Okay, so here we show a report. We want to see how many cities we have. So we want to see like how many customers we have for each city, and group by SQL query translates into relatively simple Cypher. So you just you query your subgraph, and then you say, okay, I want to get a city, but then I use aggregation function. So what happens in this case, Neo4j just does group by city and gives you total number of nodes which is connected to the city. Okay. And now we're getting a more complicated query where we're trying to use having. So having by filter. So first we get information. We calculate the total quantity sold for each product. And after that, we want to apply filter to the total sum. So as you can see, like SQL queries are getting bigger and bigger. In Cypher, it looks a bit shorter. So let me explain. First of all, we say, hey, Neo4j, give me a subgraph of all orders and products. And then we apply an aggregation. So when Neo4j executes Cypher, it works similar to MongoDB aggregation framework. You get your data, first you get your subgraph. And then this statement, it applies data transformation to the previous step. So here we say, okay, from the subgraph, we want to get a product name, and then we want to calculate the total quantity of products sold. After this stage, your current query state will give you you'll have only product name and quantity fields, and everything else is just hidden from you. So on the third line, you apply the filter. So that's where it's like a having by equivalent in Cypher, and everything else is just recorded by. So here we use this clause. As I say, this is some sort of aggregation framework for Neo4j, where you can transform the output of the previous steps. And usually it hides. So for example, if you have some data on the first step, then use this. The data from the first step is hidden, and only new fields are available for you to use on the next steps. So you can use a wildcard character to get everything. And there are like some aggregation function available in Neo4j. So the next query. So in this query, we are doing similar thing, but we try to mix where and having. So what happens in SQL? So first you apply a where clause, and you filter out some data, and then you apply group by operation, and then run the second filter. So in Cypher, it looks almost the same. So we just have two where clauses, and that's it. Okay, so here it's a more complicated query where you have multiple joins, and we want to do some calculations inside. So we do some calculations and then do grouping based on those calculations. So in Cypher, again, it looks a bit shorter because we don't use join. We don't do like a join statements. We just say, okay, this is our subgraph, and then we apply calculations on the subgraph. Okay, so it was a brief introduction into how to query data. So now let's go. Let's take a look to create, update, delete statements, how it works. So that's a standard SQL insert statement. And so in Cypher, there are two insert statements. First one is create. So create is it's a simple insert, and it doesn't check if object exists. So for example, if I implement this insert 10 times, I'll get 10 nodes with the same data. On the other hand, if you want to have an upsert, and for example, here I want to have myself as a customer inserted only once in the database, I have to use merge instead of create. And when I do merge, I have to provide some, in curly braces, you see this like custom ID equals Ilya1. So this is your filter. So it's like a primary key in SQL. So now if I run this 5 times, I will have only one object. Multiple updates are getting more interesting. So here I'm trying to add a new order, which means I have to do like several insert statements, and usually in SQL we use transactions for that. So in Cypher, it works in a more declarative way. So when you write one query, it may have multiple match and merge statements. So inside one query, you can run multiple absurd operations, but it all run as one transaction. So here I say, okay, find the customer Ilya, then find the product tofu, then let's create an order with order ID 1990. If it doesn't exist, if it exists, fine, just update the order date. And then the fourth line says, okay, now we want to connect customer to this new order. And the last, we say, okay, customer Ilya purchased order, which we created before. And then now we have to link our order to the product. And here is the last merge statement. This is our link. And in Cypher, since you can apply attributes to edges, to nodes, and to relationships, I provide some metadata to the link, the relations between orders and products. This is like one way how you eliminate those connection tables, because in relational database you usually have this like order details table where you link together orders and products. Here in Cypher, just put it, all this metadata inside into the relationship itself. And if you run this query, and if you use return statement from any like CRUD operation, you can immediately visualize the output. So that's our new models. So for update, we just use merge. And so this update, if you use default data dump from Neo4j, your order date will be a string. And this is how you do update all in Cypher. So you just convert data type of order date from string to date. So again, if you want to update your phone number, merge statement. So here we do some join and update. I want to double the quantity of my products. And in Cypher, again, it all runs in one transaction. You just say, hey, please give me my subgraph. And then you just use set keyword to update quantity. And that's it. It all runs in one transaction. So now delete. Again, in SQL, since we have like multiple tables with different relations, we have to use transactions, and we have to follow a particular order. So first we delete from order details, then from orders, and then we remove customer. In Cypher, it's simpler. You say, okay, give me my subgraph, and then use detach delete operation to remove all the nodes and edges and relations. And I think that's it. Thank you. So it was a short introduction into, okay, SQL versus Neo4j. Hopefully you will try it a bit. Thank you.
Nodes pointed to each other and
Yes, you can, because if you go like into more advanced concepts, you can try a path. So for example, you can say, okay, those are like my two nodes, and I know that there are like a 10, 20, 40 hops between them. So you can run a query saying, okay, how I can get from node A to node B, and please give me all the like shortest path or like all different paths. And usually when you run this query, you say how many hops you may have, and if you have too many of them, then you have timeout query. And I think Neo4j will also raise you an exception if there's like a cycle dependency like during this computation. And yeah, again, from my experience, depending on the server you use, up to 20 hops it can handle. Okay, more than 20 hops it will be challenging. Mm-hmm. What do you mean models? Mm-hmm. Oh yes. So yes, so it's not in Cypher. Neo4j has an ML library, so there's a set of functions which can help you to build those ML models. For example, to predict like fraud on fraud, and yeah, you can run it in Neo4j. It's like Cypher, it's like Cypher with some functions. Mm-hmm. Yes.
Yeah. Thank you for the talk. I understood some of it, but with the Cypher language, is it possible to transpile it for use on an RDBMS?
No, it's only for Neo4j. Oh, it's only on for graph database, because on RDBMS, when you represent the graph, you usually have this like join tables, like order details, but you will have those tables and you have multiple joins between them. In SQL Server, and probably, if I'm not mistaken, Postgres, they have syntactic sugar to support tree-like data structures. For example, if you have like a organization chart, like managers and like colleagues, whatever. So you can use like I think it's called like CT expression, where you can query those type of relationships, but it's more like a top-down directory, like top-down tree, not like a graph where you have like a link to anything.
And also, what is the origin of the name Neo4j? Is there Java in it somewhere?
I know it's used Java on the hood, but I don't know like why it's Neo4j. But it's written in Java. Huh.
Yeah, is there some sort of abstraction that developers usually work with when they basically Neo4j, or they really have to end up writing inside because there's a lot of object oriented.
Yeah. So
objects like Neo4j say.
Yes. So yeah, that's how it works. So you usually Neo4j, when you design a system for Neo4j, you have to come with questions, because you cannot build like abstract graph, because it will be not good from performance point of view if you just put everything like it's like a giant thing. So usually when you design a system based on that, you say, okay, this is like my top 5 questions which I want to answer. Let's try to design my data model based on those like 5 questions, and then then use it. But it's mostly objects. So when you use it in Python, you have noticed it's an object with fields with your properties. You save it, and then you query it. Yeah. And you get back objects as well. Thank you. Yeah. Oh yeah, sure. Well,
Thank you.
yeah.
This one. It's working. Thank you. Only settings and audios. Hello? 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 Not working. What? I don't need to change the name of it.
Hello, test. 1, 2, 3.
But we'll check yours afterwards.
No, no. I'm asking to say.
Oh, you want to see it?
Yeah.
Yours. Share screen. Share screen. Screen one. Yes, and allow.
So,
I'll introduce you. Yeah, let me introduce you.
Sure.
Okay, welcome back to the AI and data track. So our next speaker is Daniel Starnes. He is an open source hacker, community builder, and veteran world traveler. His extensive background includes major contributions to Neo4j, GraphQL, Prisma ORM, Timescale DB, plus GraphQL tooling and community ecosystems. And today he'll answer the question, do you really need all that prompts?
Hi everyone, it's good to be here. Swati Club, Sabadi Mai to all the Thai people. It's a pleasure to be here. I spend a lot of time here in Thailand, and thank you to all the Thai people that are going to be listening to my English talk. I do have a British accent, and I'm from the UK, so you just have to get past that a little bit. So I am the founder of a company called RConnect, and we do community and open source. So you can find us at community events, you can find us on GitHub, contributing to major open source libraries. And there's various QR codes throughout this talk that you can scan, and it will take you to that various page. So the title of my talk today is going to be about, do you really need all that prompt? And it's kind of just like a reminder for people, if you're building tools with a large language model, do you really need to pass in all that prompts to the large language model? So we're building a tool that I'm going to showcase to you today, which is called the GraphQL plain text. And what it essentially does under the hood is it builds one giant prompt based off of the API schema and then defers a response from that. I'm going to dive a little bit deeper into some of the problems we faced when building this tool and how we overcame them. So just a side note, anybody can work with AI. So nowadays there's MCPs, there's open source libraries, there's APIs. You just need an API key, and then you can start interacting with a large language model. So anybody who hasn't worked with an AI language model before, then now's your reminder to do it today. So GraphQL plain text is an open source library. It's on NPM and it's on GitHub, and it's maintained by RConnect. You can visit it by scanning this QR code. Oh, I'll just give it open a second more. Let me know if the QR code works as well, just somebody shout something if it does. So GraphQL, I'm not going to be talking about GraphQL specifically today, but I just want to let you know that it's basically an API with a schema. So the schema is on the left here. You issue a query which kind of corresponds to that schema, and then you get a response that looks exactly like that structure. And this is perfect for prompt building because you can essentially put this schema in the prompt, and then you can instead swap out the query for like a plain text string. And so what we do under the hood with the library is that we take the schema and this prompt, and then we defer the query using a large language model. So it's an open source SDK available to you to download from NPM. And you simply just pass in the type definitions here as this variable. You define which adapter you want to use. So this example, I'm using AI, sorry. And then you have an interface that you can use to issue the plain text queries, and then it will give you the response, and it will basically generate that query for you using the large language model. And this is all possible via the prompt and specifically injecting the schema into the prompt. So you can see here that this is kind of like pseudocode from our source code, is that we compress the type definitions, we put in your plain text string, and then we just give it a bunch of other context rules around GraphQL, to do with variables or comments or the structure of the GraphQL query that's generated. So this compressed type defs, we had one of our first clients on board to the library, and the second it got to any scale, basically our library just fell down because their schema was maybe 200 types or more. And this led to a ginormous schema. And so this string that we're generating now, it was huge. And sometimes it was even past the character limit of the large language models. So we needed kind of a better solution. And in fact, compressing the type definitions, so just removing the white space wasn't really enough. It didn't really satisfy coming under this character limit. And you can see here that this is like an extract of the GraphQL schema from GitHub. And it's huge. I mean, this is just like a tiny little bit, but you can imagine how many types go in there. And the second you try and use our library with the GitHub API, it took about 2 minutes to respond to any question that you asked it. So it wasn't really usable. So if you are building a big prompt, and specifically if you're putting in a schema in there, then you have to be really careful about this. It's going to take a lot of time to resolve your question. You have a higher chance of the LLM hallucinating, and it's less context aware. So we need kind of a better solution to this. So this is where Neo4j comes in. I know that the previous talk was about Neo4j, so I won't dive too far into that. But it is a graph database. It's perfect for mapping a GraphQL schema one-to-one, and it's really, really fast at traversing relationships. So there's one more point there, that it supports for vector embeddings, in which I'll get into in a second as well. So Neo4j, it basically works with nodes and edges, as you may already know by now from the last talk. But here, you know, we have the conference, I have myself, and I have a talk. And we can derive various queries from this graph, such as find me all of the talks at the conference. So if we circle now back around to the tool, in that we provide the schema, first of all, well, we want to actually add a layer in front of our prompt generation using Neo4j. And to do this, what we need to do is take our schema, and here's some pseudocode highlighted in yellow. And basically for every single type, so type logging, type user, so on and so forth, and all the fields, we basically create a vectorized embedding into Neo4j, and we store that schema as a one-to-one mapping in the graph database. And so here's just some Cypher, the query language, and it's basically set in the embedding. And the embedding is basically just like a jumbled up representation of that type. And it looks something like this. So now we can start to actually query what's on our schema and how different fields and different types are related to each other. So if we go back to the initial, which was, let's give a plain text question, let's give it a schema, and let's get a generated query as a result. Well, what we actually want to do first, instead of sending our entire schema to the large language model, let's actually use some of the existing technologies that have been around for quite some time, including the full text search, fuzzy search, vector embeddings, and let's get a subset of this schema that is relevant to this question. And so we can use Neo4j for that. And this is what we ideally would like to send to the large language model, not all of this. And we can do that quite simply with Neo4j. So Neo4j has some graph data science libraries, and you can basically compare the embeddings that we created just previously against the plain text string. And this is going to do a similarity search, and it's going to return all the nodes and all the types in that graph that are relevant to that plain text string, which wherever it is here. And then that will give us like a partial schema, a bunch of nodes and arrays and stuff like that. And what we can do is, well, this is what the query looks like, essentially back on that graph. So we just find the relevant parts. And then essentially we have a layer which pretty much sits here in this diagram, the Neo4j layer, and we convert the plain text string into a subset schema, and then we pass that directly into GQLPT, which is GraphQL plain text client. So do you really need all that prompt? There's a lot of other solutions out there for you, including vector embeddings, fuzzy search, full text search that you can use in front of your prompt generation, because you shouldn't really be using the large language model to be filtering data for you. So if you're interested in this, or if your company needs a plain text interface on top of your API, then you can visit apipt.dev. And this is what we're working on in the background. It has a lot of intelligent features such as workspaces, caching, versioning, and security, and so on and so forth. And if you're curious about why you might need something like this, then there's a bunch of use cases. A lot to do with admin panels and chatbots and so on and so forth. So thank you every one for your time today. And if you have any questions, then just let me know. Thank you. Any questions? Okay, Koppen Cup. Go ahead.
So I guess thanks for the tool. Looks good, but my question is, what trade-offs do you see when you use your proposed format? Are there scenarios where it is not so appropriate or you don't get the performance that you're looking for?
Well, so it really depends on the scale of your schema. So there's a lot of tools out there that do AI to SQL. And basically these AI tools will take your entire SQL database and then just give it to a large language model and expect to kind of derive context from it. But with this tool, you have full control of the API. So you can give GraphQL Plain Text any API that you build yourself. That includes security in front of it. You particularly explicitly say which fields should be available. So it's kind of down to you in the scale and the way that you use it. Thank you, everyone. Koppen Cup.
No, I'm just switching because now online is too late, so I switch over to local. Yes. I also have some stickers here if you want on length chain and a small logo. Yeah. Okay, so for those who want to follow along, actually there's a collab notebook which I created. It's completely free using Grok open source models and Hugging Face embeddings. So even though the slides write OpenAI, but actually the collab notebook just use all the open source models. For 55.
Okay, welcome back to the last session of the data and AI track. And next speaker is Kim Vite. Vite is a passionate tech enthusiast dedicated to building generative.
Okay, I'll just put here for another 30 seconds, then we'll officially start. Okay, let's start. So this workshop is mainly telling you why LangChain extracted it that way and how I view LangChain. So before I start, how many people use LangChain in this room? Okay, there's a few. I know the problem is that they keep on changing the imports and this kind of stuff. So I created these slides in December and I was still able to run it this month. So the exceptions have stopped changing. It's a good framework to learn now. And without further ado, let's take a look at the first extraction of LangChain. Okay, so there are actually many models by different providers. From OpenAI, we have GPT and reasoning models, the whole family tree. Next row we have AX7B, and recently they released some OCR scanning, and from Anthropic we have Cloud. Okay, so, but if you take a look and we go and use their own native API, in order to send a request, so send an endpoint request in order to get a response, notice that for OpenAI it is chat documentation.create, but for Anthropic is just messages.create. So LangChain was like, oh, why not let's just unify the interface where we can call the different models. So LangChain is how you do it. So you can install their packages. So in this case, for OpenAI, they have LangChain OpenAI, or Cloud, they have LangChain Anthropic. You guys instantiate their respective objects. Then we use the invoke method in order to send a message and get a response. So in order to, they also try to unify the way that we write messages. So in LangChain, the three different roles is actually system message, human message, and AI message. So what you need to do is that you just need to create a list of the different messages. So this is the system message object and human message object. Then after it gets instantiate the chat models. After instantiate the chat models, just use the invoke method. So as you can see, The same list of messages can be used for both OpenAI and Anthropic, which is Claude. Okay. Now let's take a look at prompt templates. So prompt templates is prompts are static, but we want to make it dynamic, which is very important for retrieval augmented generation. So what we need to do is that we need to find a way to inject dynamic inputs at runtime. So LangChain created this class called chat prompt template, where we just put a placeholder, drag in curly braces, and we just fill it in dynamically when we want it. So how we fill it dynamically? We again use the same method called invoke. Okay. And just placeholder is the key, and you can just put in the value of the dynamic value that you want to fill in runtime. So this is a very useful thing because we're not repeating the same prompt. We do not need to write this entire prompt. We can just write this template, then after that we just invoke the dynamic parts. We do not need to write this entire thing. Okay, so what is reg? Reg is just, you just put the information inside your prompt. But we need to find some way to get the information inside. So the first step of achieving retrieval augmented generation is simply just using prompt templates. So this is a very simple context, right? So in this case, I just create a template with two different dynamic inputs. So what we need to do later in our reg chain is to just find a way to insert this custom data that we need. Data will take a bit. So in this case, I did it manually. I just say AI is artificial intelligence, what is AI? So this is already reg, where the information that we need is already extracted, then we ask a question before the model gives us a response. Okay, yeah. Before that, let's go to Colab and see some code examples. Package, it actually installs two different modules, which is your LangChain and LangChain Core. So LangChain contains all of the pre-built chains that the developers have created, which they can just use. But LangChain Core actually contains the abstractions that we're talking just now. So just now we talked about messages and chat models. These belong to the LangChain Core package. So LangChain Grok is Grok is an LLM provider, which will give you access to the open source models for free. They will quite a generous rate limit, so we can just install their external package. Then in order to load the document and create a vector storage for us to retrieve our data at runtime and input it dynamically into our prompt template, we also need to use this package called LangChain Community, which is a community maintained package with all the different integrations. So what kind of integrations can you find here? You can find integrations like PDF loader, you can find integrations like Notion loader, you can find other integrations to load in all the different office files. So these are all situated in LangChain Community. So this has been quite extended for a few months. So last time at version 0.0, 0.1, we used to import the LLMs from LangChain.LLMs. But then now it has been standardized. It's either in LangChain Community or LangChain with its external package like LangChain OpenAI, LangChain Grok, LangChain Anthropic. Okay. So if you follow the guide, you will notice that you have inserted the keys in your Colab secrets. So you just need to make sure you added the Grok API key and the Hugging Face token, which is inside the Google Docs. So if you follow these instructions, you will naturally be able to add the key. Okay. So now we need to just sync the keys that we store in Google Colab into our environment variable. For us to do that, we will just import the user data function from Google.Colab, which allows us to access our secret keys. Then we import OS in order to store it as an environment variable. Okay. So then we set the environment variable to Grok API key to the one that we got in Google Colab. Yeah. And this is the same thing, but this is the Hugging Face API key. So Grok is also a free LLM provider, which actually provides you access to numerous open source models like Llama or the Mistral 8x7b. So they actually contain a list of the free models that we can access from here. Let us just take a look. Yeah, so you'll be able to access these models. Later, if you want to change the model, it's very easy. The string which write Mistral, we can just copy and paste the model name from here. Okay. So in order to start, just now we say that we need to create some messages in order to send to the different chat models. So let us just create some. Okay. So first we just instantiate our chat model. So again, it's from the LangChain, followed by the external provider name or the company name, LangChain Grok, import check the company name. So these already set up the endpoint. Like this chat Grok object already set up the endpoint to the relevant link that you need to send a request to in order to get a response. And you just set it up into a variable. So in this case, I'm just using LLM. So if I run this set of show. Then now we will just create a list of messages that we need in order to send. So in this case, I just add a system message and a human message. So for those who do not know, system message actually is a system level prompt. It says the ruler of all your messages. It is used to direct the entire conversation flow. So if you set a system message to say that you must respond in Singlish, you will respond in Singlish for the rest of your conversation. So the system message, commonly you will put some stuff like what's the tone that you want your LLM to respond, what is the persona you want it to take, and its output format. Output format can be, please respond in JSON, please respond as a comma separated list. All of this will go to the system prompt. Then after that, we have our human message, which is just it's analogous to our human query, whatever we want to ask to the model. Then we have AI message. AI message actually is the same as the assistant role in the OpenAI API, which serves to store context or serve as memory for the entire conversation flow. Okay. So in order to use the messages, you need to import it from LangChain core because it's a LangChain abstraction. Okay. So we just import the messages, then we just store it in the list. Then with this, we can just pass in this list of messages and use the invoke method. So invoke method is a bit special. Later we'll take a look at why it's called invoke, and you'll be able to get some response. So your response is originally here. You will see that your final response is actually stored in this attribute content. So you need to slice the object. So you just print the response.content and it will be tell you something about FOSSASIA. Okay. So if you want to build a simple chatbot, you just need to append whatever message that the model gives you back. So I just append the message over here. Then you have a new list which contain about the system message, human message, and AI message. So this is the flow. Then we can just add another question with messages to append human message. So in this case, I ask another question which is maybe relates to whatever the model responded to me just now. And when I re-invoke it, you notice that it will be able to give you a contextualized answer. Okay. So originally I designed this to be blank, but I think after I went through some workshops today, most people just show the code and run it. But I'll still walk through it. So the hands-on is for you to just create a simple chatbot with a while loop, so you can just ask away and chatbot will answer you. So let's take a look at how we can do it in Google Colab. We first import the chat model. Then we just instantiate it with the proper model that you want, and the temperature is to make it more deterministic. Then after that, we set up our empty list of messages. Then we start our loop. So our loop will just receive any message that the user want to ask, but we need to have exit condition. So the exit condition is to just if the user type Q, we just quit out the loop. Then if there's a question, then we will just append it to the list. Then we will invoke it. So after invoking, you will have your AI response back, then which you can just print the content to the user. Then you continue to add back the AI message response, and the loop continues again. So this is how you create a simple chatbot with LangChain. Okay. So now we are at prompt templates. Prompt templates just now is actually just prompts, but you can dynamically fill it in runtime. So in order to start it, because it's another LangChain abstraction, we import it from LangChain core. It's over here. Then after that, we want to create our template. So to create a template, just call the prompt template class, and you pass in a list of messages. So because earlier on, our messages actually, if you notice, we have some roles that we explain about, like system message and human message. So in order to also specify the role, we actually pass in a tuple of two elements. So the first element is whatever role you want it to correspond to. In this case, the first one should always be system. Then after that, it's whatever prompt that you want it to have. Okay. So in this case, I'm doing a translation task. So the phrase is the only thing dynamic at every single runtime. So I will just run it. So in order to populate our prompt template and make it an actual prompt to the model, we can just use the same .invoke method. So when we use the .invoke method of Sawadika, you notice that our prompt is actually failed. Because the human message translate phrase has now been swapped to translate Sawadika. Okay. Then now, if we take a look at the final thing, it's actually a simple list of messages that we can pass in through to the LLM. So it's a list of messages. So this perfectly fits for us to pass this into LLM before giving us a response. So if we invoke the prompt and we extract the content, we notice that we will get our final answer. So we say that the Thai phrase "Sawadika" is actually translated to "hello," which is not correct. So in order to do simple rec, just now we have seen, we haven't extracted the data yet. Now I just manually fill it in. I give it some information. I just copied this from the FOSSASIA website. Just store it as a simple text. Then the prompt template is a bit special. I will have two different keys. I want to fill in the context at runtime, and I want to fill in the user question. So the context will just be equivalent to the information. So the information is the variable that I use to store whatever FOSSASIA is. Then the user can ask a question. So the question is just, in this case, it's just a function which I set the first parameter as prompt, and the prompt is the user question which I fill in over here. So if we ask a question, who founded FOSSASIA, it will just follow the system rules. So the system rules is that it should only answer questions related upon FOSSASIA. So if I run this, it will just see whatever's over here, and you will find the last sentence. FOSSASIA was founded in 2009 by Hong Kong Tang and Mario Belling, and it will give us the answer. Okay. Yeah. So this is how this is how you can use a prompt template to achieve simple rec. But in this case, we are still manually inputting the information. In the later part, we will learn how to dynamically put the information. Yeah. Okay, let me return back to my slides. Okay. Yes. So you notice just now we are using invoke. Later we will run that. LangChain also created their own expression language. So LaSalle actually stands for LangChain expression language, which is syntax in order to compose components together. Because normally the output of one component will serve as an input for the next component. So in a simple LLM application, we just need to take the user prompt, we pass it to the LLM, and we somehow from that object they give us back, we want to extract out and serve it to the user. So what I can do is that, hey, we define this interface called the runnable interface. So the runnable interface just specifies that, what inputs and outputs should a particular component have. So just now the prompt is actually prompt template. I take in a dictionary, I fill in the dynamic values at runtime, I will get back a list of messages. This list of messages is able to pass to the LLM. And the LLM will take in the list of messages and give us a AI message output, which you can slice the content. So the runnable interface is just a way for each component to receive input and output. This is the actual definition of runnable in the LangChain website. We just say that it's a custom component, or like you stated in our function, that can be invoked, batch, stream, transform, and compose. But in this workshop, we will only be taking a look at how it can be invoked, how it can be composed. Okay, so just now, to reiterate, we just want invoke is actually just translating some input and format it into some output. So just now the prompt template, we pass in some dictionaries with key in order to populate the field, and it will give us back a list of messages. Okay. Then for the LLM, it will take in the list of messages and pass us some AI message. Okay. So how do we compose the formatted prompt to the LLM? So what LangChain do is that I think it's a little bit of operator overloading. We use this thing called a pipe operator. So the compose is just say that how can we pass information from one component to another without calling invoke multiple times. Okay. So now let's take a look at this. If I invoke it, it takes in some dictionary and it outputs a list of messages. So in this case, we just return this message. LLM takes in some message and gives out an AI message. And yeah. we are able to compose the output of this populated template in order to pass it to the LLM. What I need to do is that we just put in template and LLM, and we pipe the output of template using the pipe operator before passing it to the LLM. So in order to serve input to the first component of this chain, we will just use the input method. So in this case, the prompt template wants some context and question. So I just need to pass in some context and question, and you will automatically invoke it into the template, fills it up, return a list of messages to the LLM. Then the LLM will be able to process it. Okay, so now for intermediate Python users, you all will learn something called lambda, or lambda functions are just anonymous functions. So just now, over here, we only pass it to the LLM. We want to extract the content attribute. Because now we talk about AI message and the content attribute which we just want to show the user. So why not? We just going to write a simple function in order to return the content. So this is how you can pipe in this output parser in order to put it over here in the chain. So what I need to do is that we just say define output parser, taking in the output from LLM, which is an AI message, and just return the content. Then after that, I will just put this function inside runnable lambda, and it can be composed with all other LangChain components. So this is the power of the LangChain expression language, where we are able to also write our own custom functions and put it into the chain. So in this case, after putting it in the chain, I can just invoke it normally. Okay. Now let's do more coding exercise. So over here, we have some, this is the table that I extracted of the LangChain documentation, which shows this is the LangChain component which adheres to the runnable interface. Whatever input it should receive, whatever output it should receive. So in this case, let us take a look. We import the prompt templates from LangChain core again. We import our LLM, and we import the messages. Then after that, we compose a template over here, which is asking about what FOSSASIA is about. And then we define our LLM instance. So just now, in the earlier example, we actually needed to go and use the input method step by step. Template.invoke, fill out the template, get back a list of messages. Then after that, we pass it to the LLM. In this case, now let us take some shortcut. Let us just put these runnable components into a single variable called chain using the pipe operator. Then after that, we can invoke the entire chain, and we will get our response, which is over here. So we haven't added our custom function in order to extract the content. Let us see how we can do that. So we will use runnable lambda. We define our function in order to extract this content. So this extract content is just supposed to extract this content attribute. Okay. Now, if you pipe the output of the LLM into this our custom function, and we ask the same question, we won't be able to actually say, oh, FOSSASIA is founded in 2009. So it's a formatted message which can show in interfaces. So this is the LangChain expression language. So what is the important thing to take away from it is that the different components in LangChain often adheres to the runnable principle. So if you are building it specifically with LangChain, and building simple applications, you may not need to type LangGraph, but this is the traditional way of building it. And you are able to use your own functions inside the chain using this runnable lambda class. Okay, now for the most interesting part, we talk about data processing. Just now, our information is manually extracted. Now let's see how we can automate it. So in order to store this information, LangChain created another abstraction. So the abstraction is called document. So a document is just a simple class for storing text and associated metadata. So if I want to store some information that we want our chatbot to receive, right? We can just create a document object, populate the page content with the information that we want, populate the metadata. So this metadata thing is an interesting thing. It's actually just a dictionary of any arbitrary keys that you want. So maybe if you want to add the year of this document, you can also add it. LangChain also have different retrievers, data about it, in order to only filter information based on the metadata. So all your text that you load in LangChain, it will be converted into this document object before it's passed to some vector storage to retrieve the proper information. So in this case, I just create my document object, and you can see if I print page content, it's the same thing as hello world, print metadata is just this dictionary. So the thing that LangChain has is that it has a lot of document loaders. Just now I talk about you loading Notion, your own Notion repository, loading text files, loading PDFs. Actually, LangChain contains a lot of it. And after loading the file, which is community made, it will get converted into this class document, then this document class. So for PDFs, what happens if you're just loading a PDF is that it will just split every page, and one page becomes just one document object. Yeah. So this is how you can simply load in a PDF. Most of the document loaders are actually stored in this LangChain community package, and you can just import the relevant loader. You can see the documentation for all the different loaders. Then you can just call the class with the name of the file or the URL link that you want. Then just call the load and speed function of this class. You'll be able to get back a list of documents. So this is how easy it is to go and load in some custom PDF in order to build your first RAG empowered chatbot. Yeah. But after we load in textual information, we notice that chat models have context window. There's only a specific amount of information that it can take, right? If my document is like 10,000 words, there's really no point putting 10,000 words into the prompt, because there can be hallucination and a lot of bad things will happen. So we will need to convert these documents into vector representation. So this vector representation is a point where we can use traditional computer science algorithm in order to find out which is the most relevant answer to this particular question that the user is asking. So we need to do this process for embedding. So to embed is to, why we embed is we want to find the most relevant documents that we have stored over here in the page content for the user question, and we want to pass to the chat model to prevent hallucination and to generate more context-aware answers. Okay. So I have these three sample documents. So if I map it into this three-dimensional space of AI, cybersecurity, and web development, document 1 will be naturally closer to AI, document 2 is cybersecurity, data, and web development is reacting. So if the user asks, so I guess give it some coordinates, this is just something different. So maybe this document where this coordinate of 1, this is 0, 1, this is 0, 0, 1. After that, when the user asks a query, it will also then embed it, and somehow through the cosine similarity, we will only get this relevant information. So all other external information is blanked out. The LLM will not receive, and it will only give you back this document, which is used to populate the prompt template just now in order to get our the most relevant answer. Okay. So we need to somehow store these numbers into a vector storage. So this vector storage is for us to just store this vector representation of the documents. And with this database, we are also able to search, use the user query and search out the most relevant document. So to embed the documents, you need to import the embedding model. I originally use OpenAI, but in the Collect notebook, I'm using the Hugging Face embedding, which is free and open source. And for the vector store, we are just using this Files library, it's a Facebook library. So in order to convert all the documents just now into a vector store, just call this line. You'll call the vector store class, use the from documents method, which will convert your list of documents into this vector representation. So this is how easy it is in LangChain. Okay, so in this case, I manually just load the different documents. So in this case, from template, chat model, document loader, and the vector store, whatever I explained now. Then in order to create this vector database, what I do is that I just call the vector database class, use the from documents method, passing my list of documents over here, and passing the embedding model. Okay. So with this embedding model, we'll be able to use this vector storage, we'll be able to use this similarity search method in order to find the most relevant information. So if I type in prompts in LangChain, it will also embed this this question that I asked into the vector space and find out, oh, this is the most relevant answer that you want. So you can also set the K, which is the number of documents that you want to retrieve at one time. But there's a caveat, right? So this is one thing interesting about LinkedIn that people don't like. The vector store actually do not implement the runnable interface. I think the reason why is that the vector store can create data and you can upload some data there and you can also read data there. If you put an invoke method, it's like it doesn't know which one it should use for invoke. So what I do is that in order to retrieve the information just now, this in their research, they create a wrapper over vector store. And this wrapper over vector store is just called retriever. So a retriever can only take in a user query and get back the most relevant document. And it supports the runnable interface. The moment it supports the runnable interface, it can be invoked. So if you want to just get back the most relevant query, we create a new object, a new retriever object using the .sRetriever method. It works for all the different vector stores like Chroma or Elastic. And we can just use the .invoke method, which is slightly different from the .similarity search. Okay. So this retriever will also retrieve for you the most the relevant data. It's actually just a wrapper over .similarity search. Okay. So to sort of summarize, in order to build a red chain, we load in some data, we embed it, we store it somewhere, and we'll be able to retrieve the most relevant document at one time. So just now, we have talked about the prompt. The prompt is actually a prompt template which accepts the user question and the document information. So just now, we are loading in our document, and now we will embed it. So this is the pipeline. So the user asks a question. Once the question is asked, it will take in the user question and retrieve the most relevant information before passing it into a prompt. This prompt just gets sent to the LLM and you get an answer. This is how easy RAG is supposed to be. So the preparation of data, in this case, I never load it in. I just write whatever I wrote. So it's just a list of document object. Then you can, if you want to load in your own data, you can just use this high PDF loader with the name of a PDF for the load and split method. It will also return to you back a list of documents. Then we can embed this data by calling our vector store. Then we use the dot from documents method, which is in this list of documents over here, and we will embed. So you need to pass in the list of documents, pass in the embedding model that you want to use. Then remember, we need to convert it into a runnable in order to be composed into a chain, and we need to retrieve the relevant information. Call the sRetriever method in order to create a new retrieval object. Okay, so this is our prompt template. For a prompt template, can be just a prompt, which is answer this question based on the context only. So this is supposed to be system. Sorry. Then you can have a context over here and a question over here. So the context will be filled in at runtime by a retriever. And the question will just be the user question. Okay. Then we set up our LM, which is simply chat rock itself. In this case, it's open. Then we compose our chain together. So the first input of this chain is just your inputs for your prompt template. So in this case, is the context will just be assigned to retriever. We will take a look at why is it so later. Then the question is just runnable pass-through. Runnable pass-through will be going through later. Then we, after passing these two keys or these dynamic inputs that we need to fill at one time, we'll pass it to template. When the template is populated, pass it to the LLM before passing in the output cluster. Okay. So the chain works like that. When I invoke a question, the retriever sees this question. So because it's a runnable, it will automatically call the .invoke method on it. So when it calls the .invoke method on it, it will return to you back the list of documents, which is the most relevant to my user query. Because this is a runnable. Then this is my question, which is a runnable pass-through. A pass-through just receive whatever it takes. So it's just what to program this to differentiate. So to repeat, now retriever is actually just this thing. Question is actually just this thing. Then this got populated into a prompt template. So just now it's almost the same thing. The context is really populated, and the question is really populated. So in this case, our prompt is really fully filled. When the prompt is fully filled, it gets automatically invoked by the LLM, which will process the data. Then we'll get back an AI message with a content attribute over here, which you want to extract. Then you can just run it by now. So this is your entire red pipeline. Okay. Let's see. So let us just start it. This is how you create a document. There's because it's a LangChain abstraction, so we import it from LangChain core. And we can just create our own document object. So this is how easy it is to create a document object. Okay. So for the purpose of this red course, really created this list of specifically type documents. So let me just run it, which create this list of documents. So this is the embedding thing again. When 3-dimension, we ask a question, what does AI stand for? Then the embedding model, after it's embedded, it will use some similarity matrix and it will get back the most relevant information. And we will need to embed the model. So in this case, we are going to use some Hugging Face model. So it's actually stored in this dot embeddings. Then in order to access the API on Hugging Face to use the embedding model, we just call the class, put in our API key, and put in the model name. So the embedding model name in Hugging Face is just called all mini LM. And now we create our vector storage. So our vector storage is just something, just this FAISS. We call the doc from documents method. We pass in the list of documents over here, and we pass in our embedding model, which is this thing, embeddings. Then we need to convert it into a runnable. So this runnable is actually can be invoked, right? Then in order to limit the number of documents that get written, we can actually just pass in key. So if you run retriever.invoke, you notice that it will give you back the prompt template and chat model, even though prompt templates are above, because it's the most similar to the user question. So now we will just create the template that we have seen just now. It's just based on the full context. Context is a dynamic thing we want to populate in runtime. User query is the question is a thing we want to populate at runtime. And now we will we will pass in a dictionary into the chain. And this dictionary serves as the input to the prompt template. So, and this thing contains retriever. This retriever is a runnable. This runnable will invoke automatically at runtime, and it will give you back the most relevant document. The runnable pass-through will just take whatever I pass into the chain, which is a question. I pipe this thing to the template, which all the dynamic fields will get filled up in runtime. After that, I'll have back a list of message. This list of message goes to the LLM, the LLM processes it, and I pass it into my output parser as defined above in order to get back the information. And now, if I just invoke what from templates, it is able to say, with this ID, it's actually using inside information, which is whatever I've written over here. Yeah, from templates are used to insert information at runtime. Over here. From templates are used to insert information in runtime. So this is where you know that it's really answering based on your own context. Okay. So if you want to use item getter in order to pass in the dictionary, you can also just do it. Okay. So here, if you notice something, actually I have a document with ID, but because I'm passing in, the retriever returns to you a list of documents. So you need to extract the page content, right? So this is a more complicated chain. But I think it's still understandable. So in the list of documents, what I do is that I just create a string. I join all the different documents, retrieve the page content into this thing, and pipe it and pipe the output of the retriever to this thing. So I will just get back a normal message without the ID. Then if you print it now, you'll notice that it doesn't have the ID because we're just extracting the context. Okay. So this is the LangChain back pipeline. I'm actually done quite early. So if you want any help, you all can find me. Yeah. Thanks. Thanks everyone. Okay.
Okay, so how you can control the size of all the samples of model? Because look like to me that the chat for the ribbon document.
The retriever will only like the key parameter is the number of documents that will be passed. So if you only put one, and our document that we specifically chunk is small, it will just be that small.
The second question is that can I pass the function code to the model?
Yes, you can pass a function called, but that's not covered in this talk. If you want to do that, you can use this framework called Engram, which is quite easy to do that. So what you need to do is, you just need to create you create a function, simple function. You decorate it with the add to decorator. Then at the LLM, what you need to do is that you just use the .bytools method. So if this .bytools method, the LLM is automatically set up in order to run the model. Okay.
What happens if you want to have a question that's answered by multiple documents? Like, tell me that several times where this happened.
It can be. So in that case, the retriever actually has many different algorithms. By default, we use cosine similarity. But in this case, what I want to do is that by default, right, LangChain retrieves 4 documents. But in your case, maybe you want to use something called the BM25 retriever. So it gets the most diverse outputs, or how many times I think is increasing. Then you just set K to a higher value. Yeah, then the LLM will process, these are the actually documents that is written back to me with this particular ID. Then the LLM will see everything, then they say, only these 4 IDs actually written to me with the content that you want.
Yeah, my question is similar for about the FOSSASIA. If we have many data sources, how to ensure about the information, all information was to be, for example, I have 10,000 of sources, and I have some prompt, and I want to ensure about 10,000 of information sources was read by some algorithm, how to ensure and without computational cutoff.
In that case, maybe you want to process it with traditional NLP. Maybe it's better if you want to see, because generative AI will just read everything. But with traditional NLP, you can actually go and count how many documents have this particular content push inside. But if you want to do it in LangChain, I don't know why you can use that. You can actually just split the workload amongst different LLMs. So maybe you can have a hierarchical system where there's a parent node which say, this will count. Then you just separate your different documents. Then the different documents just pass into a different LLM. The LLM will just give a number this is the amount of documents that actually stated this information. Yeah. Then the parent will just say, since you want give this answer, then this is the amount of times this information has appeared in the document. Is that your question?
But how we ensure that is there any law or anything to ensure about all of information have trace of query if I concern about the traceability of
the traceability of
the data source. For example, auditability, if you want to audit about the maybe some of data source was.
So you want to rank? You want to rank the data? I think that one belongs to the evaluation part. So LangChain has this it's commercial, it's called LangSmith. So LangSmith actually has this custom evaluation where the LLM is used as a judge to see how good is this data written back to you. There's a lot of this kind of open source evaluation frameworks used for this. So naturally we don't use this, we just use we just use an evaluator of LLM as a judge in order to tell me the flow of information. Okay. Then more question? Okay, no. Yes. I say more stickers if you want. I'll play at the counter if, yeah.